Hello guys, welcome back to Math Zone African Motives. We are still on our revisions, and this is from the Northwest province that we are going to consider for our grade 12 mathematics paper 1, which was written in June 2025. All right, so that is what we had, and I'm not going to waste your time here. 150 marks, 3 hours time that you are required to answer the 10 questions that you are given. So make sure that you read the instructions and the information that you are given here, especially your answers. They must be to two decimal places unless stated otherwise. So that was the condition. So I'm not going to waste your time. This is what we had on our first question, question number 1. So make sure you download the question paper. Just check the comment section. All right. So if you check the comment section, you are going to see I'm going to pin a comment there where you can download the question paper, or you can actually download it from the description of the video. So that is what we have, so that at least you can properly see the questions that we are having here. The first part, 1.1, you are given to solve for x. All right, we have gone through a lot of questions like this in our algebra from our grade 11 mathematics, where you are supposed to solve these for x. All right, so 1.11 we are given, that is x squared minus x minus 12 is equal to 0. All right, so for 3 marks, and you're not told that your answer must be correct to two decimal places. That is going to be the factorization. So simply apply your factorization in this case, or you can use your quadratic formula. It's not a problem. So in our case, the coefficient of x squared is 1. So I'm just going to have two brackets, equate them to 0 here, put x and x. Then consider the factors of what? The constant. This is your constant, which is supposed to give us -1, the coefficient of what? Of x. So what are the factors of what? -12. There are so many factors. So many factors. But the one that will give us a -1 when we add, that's -4 and what? And 3. But for the sake of revision, we're going to try -12 and 1, 12 and -1, -6 and 2, 6 and -2, -4 and 3, 4 and -3. All these are factors of what? -12, the constant. But of these, when you add now, where are you going to have what? A -1. It occurs on these two, -4 and what? 3. So that is the one that you're going to consider, -4 and a +3. This is what? A +3. So that is the condition, guys. For us to have or to obtain a 0, it means one of these brackets from the product is supposed to give us what? A 0. X minus 4, that's a 0. Or the bracket of x plus 3 is equal to a 0. So that is it. So our x values, we're going to be a +4 from that negative, and -3 from the positive that you are given. So these are the possible values of x that you're going to obtain from the given quadratic equation, which we can also just apply our quadratic formula. All right, so some of you guys, you are used to that, and because of the formula that you are already given, some of you guys, you just, all right, let us consider the quadratic formula, because I already have the formula here. So I simply use that formula. It's not a problem at all. You can easily use that. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. All right, so that is it. In our case, our a is what? The coefficient of x squared, which is 1. Our b is -1, and our c is the constant -12. So simply substitute that into the formula. So that's negative. Your b is what? Negative 1 plus or minus the square root of b squared. Negative 1 squared minus 4. Your a and your c is what? Negative 12. Substitute the values properly. Then 2 times a, that's 2 times 1. So that was it. Negative, negative, that's a positive. So just write a 1 here, plus or minus the square root of, just try to simplify what is under the square root. That is negative. All right, let me just bring my calculator back to the normal mode. All right, negative 1 squared minus 4 times 1 times a negative 12 like this. That is going to give us 49. Everything over 2 times 1, which is what? Which is 2. So you can easily use your calculator, separate these. You are going to obtain same answers. For a positive, you're going to have 4. For a negative value, you're going to obtain what? A negative 3. So that is one and the same from what we had using what you are using our factorization. We can also use the quadratic formula. That is not a problem at all. So 1.12, you are to use the quadratic formula this time, or your completing of the square method, since you are told that your answer is supposed to be what? Correct to 2 decimal places. All right, so that's our 1.1.2. All right, 5x squared. All right, so here I need the format ax squared plus bx plus c is equal to 0. So I have to take the 9 to the other side. So that's 2x. 9 is going to be a negative there. All right, so the format first. Then from there, ax squared. So our a is what? Our a is 5. Our b, the coefficient of x, and our c is the constant, negative 9. Substituting into our formula. All right, guys, I erased the formula. Let me just rewrite the formula back here. Then substituting our values, it was going to be negative b, that's 2, all right, plus or minus the square root of what? 2 squared minus 4. Our a is what? 5, and our c is negative 9 over 2 times a, that's 2 times 5. So that's it here, negative 2 plus or minus the square root of what? Simplifying these numbers under the square root, that's 2 squared. All right, let us just have a bracket again. As it is here, if you to express it in that manner, it's not even a problem at all. All right, so that can be actually expressed in any of the formats or manners that you understand, right? So let me just have this bracket. That's 2 squared. Sorry for that. Minus 4 times 5 times what? Times negative 9. And this was going to give us 100 and what? 84. Everything over 2 times 5, which is 10. So you can separate this plus or minus, then obtain the values of x to what? To 2 decimal places. Let's start with the positive. All right. There we are given. All right. I'm supposed to go back. All right. Sorry for that. I need to go back here. So this was going to be minus 2, all right, plus the square root of 184 over what? Over 10. So let us have this. We can simply do this, fix our calculator to 2 decimal places like this. That's going to be 1,16. All right, so that's 1,16, or x is equal to the negative. Let us put a negative here, and our answer is going to be negative 1,56. All right, so this is what you are going to have as the values of x to what? 2 decimal places. All right, let us consider another part where you have an inequality this time, which is our question 1.13. There we are given 18. All right, so that's 1.13. That's 18 minus 3x minus x squared is greater than or equal to 0, of which you can actually work out as it is But in most cases, you guys, you understand when the coefficient of x squared is a positive. But what I'm simply saying here, you can do your factorization. After that, you consider the critical values, then determine the exact solutions. Or you can rearrange and make the coefficient of x squared a positive. Make the coefficient of x squared a positive. So how is that possible? We have to divide by -1 each and every term, so that this will be a positive. Negative, negative cancels. That is going to be positive x squared. All right, the same thing, negative, negative. That is going to give us what? Positive 3x. And here, positive and a negative is going to give us a -18. But remember, this is an inequality. The moment you divide by a negative, the inequality sign changes or it reverses. So it is going to be less than or equal to. The inequality sign reverses, it changes. So it means we have a new inequality to consider. This is a new question now. We are no longer considering where it was greater than or equal to. We have got a new question to consider now. Where the coefficient of x squared is 1. So it'll be easier for us to simply factorize this part, all right? It's going to be x and x here, considering factors of what? The constant -18, which will give us what? A +3 when you add. So there are so many factors of what? -18, guys, but the one where we're going to get a +3 must be 6 and what? -3. All right, if you multiply this, you're going to obtain -18. If you add, that is going to give us a positive what? A +3. So that's +6, negative what? -3. So from this, you can find or determine your critical values. All right, where you're solving this as an equation, x plus 6 must be equal to 0. So that will be a -6, or x minus 3 is equal to 0. So x will be equal to what? A +3. From the critical values, we can determine our solutions. Either you're going to use the graphical method, the number line, any method that you understand. So from the graphical method, we are going to consider this as a function of x. This whole part as a function of x, which is what? Less than or equal to 0. So this function of x, when it is less than or equal to 0, it simply means that's considering below what? Below the x-axis. All right, the coefficient of x squared from our quadratic here is what? Is 1. Remember, this is our new question now. The coefficient of x squared, that's our a, is greater than 0 there, where we are considering positive values. So it is going to be what? Concave up. We are going to have our graph being what? Concave up. So that is it, where these are the solutions or the roots to the graph. The -6 on the negative side, then the 3 on the positive side. So where is this function below the x-axis that is less than or equal to what? To 0? Where is it below the x-axis? This is the region where our function is below the x-axis. It is bounded in this region. So in between these values, it simply means our x is going to be greater than or equal to -6, less than or equal to 3. In between these, all right, remember there's an equal to on our question, so we must have that also on our solution. So that will be the values of x from the given inequality. All right, it was a little bit straightforward, just your factorization, finding critical values, then you use any method. You can even apply the number line. It is in your hands, guys. All right, let us consider 1.14, which is our equations under seds. Remember our seds. 1.14. You are given 6 minus the square root of x plus 4, and that is equal to x plus 4. So what we simply need here is to isolate the set, this part here. We just need to isolate this one, or simply make it the subject of the formula. It is a negative here, so I can avoid this to be a negative. Take it to the other side of our equation, which is going to be a positive square root of x plus 4. It was a negative, so the moment it crosses the equal sign, changes the sign. Then I'm going to take the remaining, these terms which were on the right-hand side back to the left-hand side. So meaning to say, we are going to have 6 already, all right, on the left-hand side. The 4 to the other side is going to be a negative. X to the other side is going to be a negative. So this is what we have. And these are like terms. So you can easily subtract. 6 minus 4, that's 2. So 2 minus x is equal to the square root of what? X plus 4. As we have isolated our set, we can get rid of the square root by what? Squaring both sides. So we have to square both sides. All right. So this is the idea, which is going to give us x plus 4. Remember, this neutralizes, so that's x plus 4. And here you're going to square. Remember, your a minus b squared. The square of a binomial is going to give us a squared minus 2ab plus what? B squared. So this was going to be 4 minus 4x plus what? X squared. Or simply expand the two brackets, 2 minus x into what? Into 2 minus x properly. This is what you're going to have at the end. And as you can see, guys, what we have formed, or the resulting equation, is simply a quadratic. The highest power is 2, quadratic equation. These ones that we're dealing with. So remember the format of a quadratic equation: ax squared plus bx plus c is equal to what? 0. So you have to consider what? Your format. All right, so here we're going to have x squared. All right, then considering the like terms, there is minus 4x and there is x, but we have to take this x to the other side of the equation. So it's going to be a negative. Negative 4x, negative x. Simply negative 4 minus 1, that's minus 5x. The same thing, the 4 to the other side is going to be a negative. So that's 4 minus 4, which is what? Which is 0. So there's nothing here. We're going to equate to 0. The resulting equation, being a quadratic, can simply be factorized. We've got two terms, guys. So instead of you using the quadratic formula, this and that, you can simply factor out the highest common factor between these two terms, which is actually x. All right, so x divide this and this is going to give us x minus 5x, and x is going to give us negative 5, and that's equal to 0. The product of two terms to be equal to 0, it means one of these must be equal to 0. So that is the consideration. So x is equal to 5, x is equal to 0, or x is equal to 5. Remember, this is from a set. You are supposed to test these values that you have obtained, where x is 0 and where x is what? 5. Let us test. You simply put back into the original equation, the question that you're given. In place of x, when x is equal to 0, put a 0 here, put a 0 here. So it was going to give us 6 minus 0 plus 4. That is going to give us 4. Square root of 4, that's 2. All right, that's equal to 4. All right, 6 minus 2, that's 4, and that is equal to 4. All right, so as we can see, the left-hand side and right-hand side are equal when x is equal to 0. So we need this one. All right, what about when x is equal to 5? This here is now a 5, this is a 5. So it was going to be 6 minus 5 plus 4, that's 9, and the square root of 9 is what? 3. And that's equal to 5 plus 4, that's a 9, 6 minus 3, that's a 3, equal to 9. These two are not equal. So as you can see, when x is equal to 5, the left-hand side and right-hand side are not the same. So x cannot be equal to 5. So x is equal to what? X is equal to 0. So that is the final answer that you are going to have. So that was the basic idea on this question. It was also a direct question. All right, let us consider 1.2. From here, we are almost done, guys. All right, 1.2, you've got solve x and y simultaneously. All right, so this is what you're given, two equations, and we are supposed to solve this simultaneously. All right, just for the sake of space, I'm just going to write these two equations here. That's our 1.2. All right, so the first equation, it was given as 2y minus x, which is equal to 3, and that's a linear equation. And the second one being a quadratic. So remember our concept from our grade 11 mathematics that you make x or y the subject of the formula from a linear equation. All right, this is a quadratic. So you need from this linear, let us make x or y the subject. Which one is easier? X is easier to make the subject from our equation 1. We're simply going to take it to the other side, then 3 to the other side. We are done. So that is the concept. So let us make x the subject. It is easier that way. Make x the subject. That's from what? From equation what? From equation 1. So if I take x to the other side, I'm going to remain with the 2y. Take 3 is going to be a negative 3, and that is equal to what? That is equal to x. All right, so this is what I have. X is equal to what? 2y minus 3. So this is going to be my equation 3. All right, I made this the subject of the formula from equation 1. So I'm going to substitute it back in what? Equation 2. So simply substitute that equation 3 into what? Into 2. All right, so let us substitute, guys, in place of x. All right, so the first one is y squared plus 3x. So in place of x, you are going to substitute 2y minus what? 2y minus 3. All right, minus 2xy. Remember, minus 2xy like this, all right, is the same. All right, so here actually there was no need of like, this is the, all right, it is the same actually as minus 2y. You can start with this y, then x. So this is like AB is equal to BA. So minus 2y times what? Times x. So that is going to be minus 2y times x. Our x is what? 2y minus 3. All right, so that was actually what it means on this part. Yes, you can write it as this minus 2. Our x is what? Our x is 2y minus 3. Then you multiply by y. But know that these two terms are outside of the bracket. So you can simply write as minus 2y into 2y minus 3. So be careful on how you expand brackets. Most of you lose marks on that part of expansion of brackets. Everything will be fine, but when you just try to expand those brackets, you forget like your previous stages. So guys, do not leave any gap between your grade 10, 11, and 12. Never leave a gap because everything is taken from those previous grades. All right. Anyways, this is what we have, guys. We want to solve for y in this case. So we can simply expand brackets. All right, so that's y squared plus 3 times 2, that's going to be 6y here. 3 times this, negative 9. Negative 2 and 2, that's going to be negative 4y squared. Negative 2 and negative 3, that's a positive 6y, which is equal to 0. So we also have to consider collecting of like terms. As we can see, guys, we are forming a quadratic equation. So considering the part of y squared and y squared here, there is 1 and what? Minus 4. So 1 minus 4, that's a negative 3. Negative 3y squared. All right. Also, we've got like terms, the part of y here, 6y and 6y. So you simply have to add 6 plus 6, that's a 12. So that was going to give us plus 12y. Then negative 9 is on its own. It is on its own. You cannot simplify it any term. Yes, as we have got our quadratic equation, someone can simply solve this using the quadratic formula. It is fine. But you can also reduce your equation considering the highest common factor between these numbers, negative 3, 12, and negative 9. You can see that 3 is the highest common factor, but we can also avoid working with what? The negative. So we can make it be a positive by dividing by what? A negative. So it's going to be negative 3 throughout, the highest common factor of these numbers. So that is it here. That's going to be y squared negative negative. I mean, positive negative, that's a negative. And that is going to give us 4y negative negative. That will be a positive. 9 divided by 3, that's a 3, and that is equal to 0. All right, so this is the concept. As we can see, guys, if you have reduced this equation into this, it is easier even for you to factorize, even if you do not understand your factorization here. When the coefficient of y squared is 1, you simply have to consider two brackets, simply put y here and y there. Then what is that you're going to consider? Products or what? Factors of 3, which will add up to a negative 4. So which are the products here? 3. Thus we've got 3 and 1 minus 3 and minus 1. So the part where we are going to obtain a negative 4 when we add them is negative 3 and negative 1. If we add these two, we are going to obtain a negative 4. So we need negative 3 and negative 1. So that is the condition. Two brackets equal to 0. It means one of these is equal to 0. So y will be equal to what? A positive 3, or y is equal to a positive 1 on the other side. So these are the values of y that you have obtained. So to find the values of x, you can simply substitute back into equation 3, where we have made x the subject of the formula, remember, in our equation 3. So you can simply substitute back there. We have x as the subject, remember, in equation 3. So you can find x from there. All right. So here we're going to find the values of what? The values of x. Remember that. So from equation 3, where we have made x the subject, remember we said x is equal to what? 2y minus 3. So that's what you're going to have. When y is equal to 3, that's going to be 2 times 3 minus 3. In place of y, we put 3. So x was going to be 6 minus 3, which is what? Which is 3. All right. The same thing. When our y is 1, substitute 1 in place of y. What are you going to have? X is going to be 2 minus 3, which is what? Negative 1. So that will be the values of x. All right. So that is it. When y is 3, x is 3. When y is 1, x is what? X is negative 1. So you can easily play around with your questions, guys. That's easy part. Just play around, revision, do your basics. All right. Let us consider another part, which was 1.3. All right. So this one was 6 marks. All right. 1.3, 4 marks. They were given a statement to consider. Whenever you're given this statement, if, put that into consideration. Simple. Put whatever that you're given there into consideration. So if x cubed minus y cubed is equal to this, remember the factorization of what? A difference of 2 cubes. We are talking about what? A difference of 2 cubes gives us this, which is exactly our factorization. So now they are saying, show that these two brackets can be expressed as this, where a, b, will be elements of what? Rational numbers. All right, guys, are we seeing that? This is the factorized part here when it is factorized. So this here is equal to this. So this part here, that is the factorized part where we've got x minus y into x squared plus xy plus y squared. It was taken from where? It was taken from x cubed minus what? Y cubed. So meaning to say, in our case, 3 minus 1 over the square root of 5 into this part as it is. All right, let us just rewrite 3 over the square root of 5 plus 1 over 5. It was taken from x cubed minus y cubed. What is our x? Our x is 3. So it was taken from 3 cubed minus what? Y cubed. What is our y? 1 over 5, 1 over the square root of 5. 1 over the square root of 5 cubed. That is where it was taken from. So simplify until you can have your answer in that format. That is the question you're done. All right? 3 to the exponent of 3, that is 27, minus, there we are supposed to simplify properly. So it is 1 over, all right, 1 to the exponent of 3, that's 1 over 5 to the exponent of 3, guys, simply means, this square root of 5 to the exponent of 3 simply means the square root of 5 is going to multiply itself 3 times like this. So square root of 5 times square root of 5, that is going to give us a 5. Remember from our laws or for sets, square root of a times square root of a gives us a. So if these two are the same, you are going to obtain that number. And out of the square root, actually, then this here is 5 times what? Square root of 5, which is remaining. So that's 5 square root of 5. All right, so that is 5 square root of what? Of 5. This is what you're going to have from the simplification of what? The square root of 5 to the exponent of 3. All right, but you can see that it is not yet in this format because here it is 1 over 25. You must have 1 over 25 square root of b. It means they rationalized the denominator here. They rationalized the denominator. I mean the z, which is our denominator. All right. So our z is in the denominator. We are supposed to rationalize that. So how do we rationalize? We simply multiply both the numerator and denominator by what we have in the denominator like this. All right, 5 square root of 5. So you multiply both the numerator and the denominator by this term in the denominator. When you are given a single term, for a single term, when you are given something like a minus square root of b, you multiply by the conjugate, which is you introduce a negative. So it will be a plus square root of b. But in our case, it is a single term. You multiply by that single term, all right? So that is it. 27 minus the numerator times the numerator. That is going to give us 5 square root of what? 5 square root of 5. All right, over what? The denominator, if we multiply 5 square root of 5 times 5 square root of 5, what are we going to have? It is like this, 5 square root of 5 times 5 square root of 5. 5 times 5, that is 25. The square root of 5 times square root of 5 gives us what? A 5. Remember here, square root of 5 times square root of 5 gives us what? Gives us a 5. So 25 times 5, that is going to give us 100 and what? 25. So this is same as over 125. All right, so that is what you're going to have. And here, 27 minus what? This here, minus 5 over 125, that is going to give us minus 5 over what? 125. That is going to give us negative 1 over 25. Negative 1 over 25. So you remain with what? The square root of 5. Remember, we simplified this. So you're going to remain with what? The square root of 5 separately like this. This is exactly the format that we are given here. If we are to check here, it is supposed to be given in the form A. So this is our A minus what? 1 over 25 square root of what? Square root of b. So that is the condition. So here it was just to simplify. So that is what we have there. So you see, guys, whenever you've got this statement, if, in your if this, apply that, use that put that into consideration. All right. So in our case, that is what we had. Let us consider question number 2, which is part of our number patterns now. So we are given this part, all right, which is actually, all right, 8 marks. All right, no problem. Let's see. So that was given the quadratic number pattern, all right, on our question number 2. This is a quadratic, and from there we are given 2.1. Write down the fourth term of this quadratic number pattern. Remember, a quadratic number pattern is the one that has the constant second what? Second difference. So we can actually use that concept to say if you're given 2, 7, 16, and so on. All right, 2, 7, 16, and so on and so on. These are our terms, like we've got our T1, our T2, our T3. So let's find the first difference is T2 minus T1. T2 minus T1, that's going to be 7 minus what? 2, which is 5. T3 minus what? T2. So take note, this one minus this one. That was going to give us a difference of what? A difference of 9, all right? We have a 16, all right? So that's our first differences that we have. Then here, the second difference, that's 9 minus what? Minus 5, which is a 4. So remember, the second difference is the same. It is constant throughout this one. It is the same. So we can trace with that one. We can work with this 4 to say if 9, if we're going to obtain another term here, we're simply going to add a 4 from that because this is going to be a 4. So you're simply going to add what? A 4. So 9 plus 4 was going to give us a 13. So that's the same thing on our 16. To obtain the next term, it was going to be simply 16 plus what? 16 plus 13. And that was going to give us what? A 29. So that is the fourth term that we need. Remember, this is the first, second, third. So our T form was going to be 29. So do not worry about these guys because you are also going to use it in the calculation of the nth term. So use this to find any other term, all right, any term that you'll be asked on your question. Then from there, we are being asked now to determine the general term, which is our Tn, for the quadratic number pattern that you're given, all right? So like I said, do not even worry about this because you're going to use that. So this information is the same that we're going to apply on the second question to find our Tn. Remember, for a quadratic, Tn is supposed to be equal to an squared plus bn plus c, where from our second differences here, 2a is equal to that second difference. All right, so divide by 2 by 2, a is equal to 2. Remember that. There are so many ways that you can actually use. So many ways, guys. All right. And also, this term from our first differences is equal to 3a plus what? 3a plus b. So that's our 3a plus b equal to what? 5. So that's it. Our a is what? 2. So that's 3 times 2. Our a, remember, that is what? That is 2 plus b equal to 5. That's going to be 6 plus b equal to 5. So b is equal to what? This to the other side was going to give us a negative 1. 5 minus 6. That's what? A negative 1. Then the first term is equal to a plus b plus what? C. That equals to the first term. So you can easily or simply use that to find the value of c. A plus b plus c is supposed to give us what? A 2. Where our a is 2, our b is negative 1 plus c is equal to 2. So combine these 2 plus minus 1, that's going to be 1. all right, plus C equal to 2. So take 1 to the other side. That is going to be a negative there. So C is equal to 1. All right, 2 minus 1. So this is it, guys. Substituting in this formula, our A is 2. So that's 2n squared. Our B is what? Negative 1. So that's negative n. Our C is positive 1. So that's simply a 1 like this. So you have got the Tn, the general formula of the given quadratic number pattern. All right, so this was just a normal question. We are used to that. All right, then the other part is to calculate the number of terms in the number pattern, the number of terms to find what is the value of n. Why are we being told to find the number of terms if we are not given the Tn to equate to? Because they know from these terms that we are given, as you had these terms T1, T2, and so on and so on, you are given up to the last term, 862. That's our last term. So that equals to your Tn. So the question is simply from that quadratic, find the value of n or the number of terms there if your Tn is equal to what? 862. So that's it. Our Tn is equal to 862. Numerically, that's the numerical value of the last term. Whereas our Tn in general is the general term, we have it, we calculated this, all right? Remember, we determined this. So we are going to take this Tn, all right, from our question. This is our Tn, all right? Let me try. No problem, it's not going to work. I thought this is going to work. I wanted to just shift this one up. So that's 2n squared minus n plus 1, our Tn that we calculated. So you equate that one to the last term you are given it. So from there, you can calculate or determine the value of what? The value of n. That was simple like that because these two, they are equal. So therefore, 2n squared, our Tn, as an expression is equal to the numerical value of what? 862, our last term. So solve n from there. All right, so for n, so this to the other side was going to be a negative 1 minus 862 is going to give us negative 861. And that's equal to what? That is equal to 0. So here we can use, yes, we can apply our factorization, is fine. But for these bigger values, I just advise you guys use your quadratic formula at once. So solving for n is going to be negative b plus or minus the square root of what? B squared minus 4ac over 2 times a, where our a is the coefficient of n squared. So that's a 2. The coefficient of n is our b. So that's negative 1, and our constant will be negative 861. Substituting into the formula that we are given, here we can find the value of n, all right? So n is equal to, right? So let us just see here. Negative b, so that's negative 1, plus or minus the square root of b squared, negative 1 squared, negative 4 times a times c, negative 861. Everything over 2 times a, that's 2 times 2. All right, so I can simply substitute these values, then simplify from the calculator. That was gonna, all right, let me just try to simplify this. So negative, negative, it's gonna give us 1 positive square root of, that's gonna be, all right, so just play around with your calculator here. 4 by negative 1 times negative 861. All right, so here I have to bring back my calculator to the normal mode. All right, so that's negative. What? This cannot be a negative. This cannot be a negative. Our A, 4AC, 4AC, 4AC. This is 4AC, 4AC. Our A is what? Our A is 2. All right, so be very careful on that. Be very careful on that. All right, substitution of your values. That is something that you must be very, very careful of. All right, so let us put a 2 here. Let us see, put it to, right, this makes sense, all right? 6889 over what? 2 times 2, that is a 4. So from there, we're going to find the values of n, all right? Starting with a positive, that was going to be 1 plus the square root of 6889 over what? Over 4. And that is 21. So we've got 21, or n is equal to, let us put a negative here and see what are we going to obtain. That was going to be negative 20 and a half. All right, negative 20.5 as a decimal. All right, so actually n cannot be a negative. We talk about number of terms. So therefore, our n was going to be what? Our n was going to be a positive 21. All right, so meaning to say, in our case, if our n is equal to 21, we're talking about that it being the number of terms. All right, so here, that is it, the number of terms in the pattern. So meaning to say that is going to give us 286. That T21 equals to what? 862, the last part that we can see from our given terms. So that is it. That is it for 8 marks on question number 2. All right, it can be like that. Question number 3, let us see here for 12 marks. All right, let us see what we have. Given this geometric, all right, so we are already told this is what? A geometric series where we talk about what? The constant ratio. So already we are given that, so we're just going to consider 3.11, write down the general term of this series, all right? T1, T2, T3, and so on. So remember, our Tn is going to be AR to the exponent of n minus 1. So A is already there. Our first term is what? Is 2. Then we need our R there, which is simply T2 over T1 for a geometric. So that's 6 over what? 6 over 2, which is 3. So that was it, guys. Substituting this is going to be A, which is what? 2. So that's 2 times our R is 3 to the exponent of what? N minus 1. So that is what we have. And from this, you are given here 3.12. Calculate the value of m such that this summation here is equal to this. All right. So remember, here is simply sum of terms. This is what? Sum of terms. So here they were just playing around with us, guys. If you check properly the presentation that we are now given, they just wanted to confuse you guys. All right. They just wanted to confuse you guys, all right? The first one was 3.11. Did I even write it? Did not even write. This is 3.11. All right, so this is now 1.2, right? So here they just wanted to confuse you guys. Look what is happening here. The summation of this whole part here, 2 over 3 times 3 to the exponent of n is equal to 59048. If you are to check properly, this part under our summation, inside this summation, is the same as this one. All right, you're not going to start a big, guys. All right, I want to consider the series where it was taken from. Is it an arithmetic? All right, if it's a geometric because it's raised to the exponent of n, then I start by the terms when n is equal to 1, when n is equal to 2. If you check properly here, 2 times 3 to the exponent of n minus 1 can be written as, all right, this part can be written as 2 times 3 to the exponent of n times 3 to the exponent of negative 1. It is the same. Where 3 to the exponent of negative 1 is 1 over 3. So it's 2 times 1 over 3 times 3 to the exponent of n, where 2 times 1 over 3 is going to give us what? 2 over 3 times 3 to the exponent of n. Exactly this part. They just wanted to play with you guys. So if you are to consider that this here is the presentation of the nth term that we had from this series. So they are simply saying from that consideration that we had from these terms, from those terms that we had before. If the sum of terms is what? If the sum of terms is equal to 59,048, where you know that your A is equal to 2, because when N is equal to 1, N is equal to, we are talking about the first term. So definitely you're going to obtain 2. Your R is equal to 3 because it was taken from this series, remember. This is the same way we took our nth term from this series. So nothing has changed. So we still have the same value of A, the same value of R that we had from the previous series. Remember, this is the same. So therefore, we can determine the value of M. All right. Remember, number of terms is going to be equal to, all right, number of what? Number of terms here is going to be equal to the upper, which is M, minus the lower, which is 1. Then we add a 1. So it was going to be M minus 1 plus a 1, which is M minus 1 plus 1, that's a 0. So that's our number of terms is going to be represented by what? By M as it is. So remember that our Sn as of a geometric, we are also given this from our formula sheet. All right, this is where we have got our sum of terms. So you can simply use that formula, all right, to determine your sum of terms. All right, I mean to determine the value of M, because there we are asked to calculate or to find what? The value of M. So our Sn is equal to A into R to the exponent of n minus 1 over R minus 1, where the sum is what? Numerically given as what? This 59,000 and what? For 8. So that's 59,000 and 48 is equal to A being the first term. When n is equal to 1, the first term is what? Is 2. Into our R is 3. So that's 3 to the exponent n for the number of terms is represented by what? By M. So that's to the exponent of M minus 1. Everything over R minus 1, 3 minus 1. You are done. So let us solve for M, just like that. So this was going to give us 59048, which is equal to, this here is just going to divide and cancel. So it's 2 over 2, which is what? 1. So you're going to remain with 3 to the exponent of M minus 1. Taking the minus 1 to the other side, that was going to be a positive 1 here. So you're going to obtain 59,049 equal to 3 to the exponent of M. So to find M, write these in the same base. So this in the base of 3, all right? Simply use your calculator. 59,000 and what? And 49 is equal to, then you press this shift, then you press fact. All right, so that's 3 to the exponent of what? 10. So that's 3 to the exponent of 10 equal to 3 to the exponent of what? Of M. So as we have got the same base of 3, it means these powers automatically are equal. So therefore, M is equal to what? M is equal to 10. So that was the consideration from what we had, of which there are so many ways to play around with this type of a question. But from this, that is what you could have just considered. It was just from the previous series. They just wanted to play around with you guys, to confuse you guys. They want that. All right, so just be careful. All right, 3.2. The first term of an infinite geometric sequence, infinite, that's why you consider what? The sum to infinite. All right? So we're given that the first term of that is what? Is 3. So that's our first term, T1, which is same as A, that's 3. And the common ratio is what? 1 over 2. Our R is 1 over 2. And it makes sense because R is supposed to be greater than minus 1, but less than 1 for a what? An infinite geometric, which is actually converges. So we are being asked here, determine the value of the third term of the sequence. All right, remember, guys, whether it is not infinity or it is infinite, but it is what? A geometric sequence. So this here does not stop us to calculate the nth term the way that we are used to. The general formula is still the same for Tn. If our Tn is ar to the exponent of n minus 1, therefore we can find the third term because we are given this. So our T3, third term, is equal to what? Our A is what? That's 3 times our R is given as what? 1 over 2 to the exponent of n minus 1. Remember, our n is what? Is 3. So it's going to be 3 minus 1. So we can determine the third term direct like that. So that's 3 open bracket 1 over what? 1 over 2. That's to the exponent of 3 minus 1. And that is going to give us what? 3 over 4, just like that. So this is our third term. 3.2 to determine the value of what? The sum to infinite, as we are given. This is what? For a sum to infinite. So we can easily substitute again into the formula, all right? If you do not know the formula, guys, it is given from your formula sheet when from this information sheet where we've got this sum to infinity. Remember the condition a over 1 minus r. So you can easily substitute that into your formula. All right, so our sum to infinity was going to be given by a over 1 minus r there. So remember our a is given as the first term, which is what? Which is 3 over 1 minus our r is given as what? 1 over 2. So that was the condition. This is going to be 3 over 1 minus 2. That's a half. And using your calculator, this is going to give you a 6. Or you can just use your calculator on this stage. All right. So that was your sum to infinity. 3 over what? 1 minus 1 over 2 like this. So that's a 6. Okay, so that was our 3.22. Let us consider another part, 3.2. We are given here if powers of 6 is removed from the sequence, all right? So this is a new question on its own. That is, the powers of 6 are removed from this sequence. All right, what is the actual type of sequence that we're given originally here? 1, 2, 3, 4, and so on. There's a difference of 1, a difference of 1, a difference of 1. So the original sequence that we're given here is what? An arithmetic. It is what? An arithmetic where we can determine, because here they're talking about what? If powers of 6 are removed, determine the sum of the remaining terms. It's about the sum. So the sum of the remaining terms is simply supposed to be taken from the sum of all terms that were given, forming this arithmetic. Remember, all terms, they form what? They form an arithmetic. So all terms here, they are how many? It's 1, 2, they are counting 1, 2, 3, up to what? Up to 8,000. All right, so let us just all terms here minus the sum of what? These ones that are being removed, the ones for powers of 6. The sum of what? Powers of what? Of 6. All right, so this is what we are going to actually have. So all terms, they form an arithmetic. All right, so that is the sum of all terms forming an arithmetic. This is our first term, this is our last term. So we can find the sum of those terms. That is for all terms. All right, so that's an arithmetic. So you can simply use the formula n over 2 into a plus what? A plus l. Or you can use this one is still one and the same for the sum of terms. This one, you're still going to obtain the same answer. But when you are given the first term and the last term, remember, guys, I said this is the shorter one that you can use. So remember, all terms, they form an arithmetic, and all of them will be what? 8,000. So we're talking about sum of 8,000. There are 8,000 of them. 1, 2, you're counting from 1, guys. There will be what? 8,000. So that's equal to, our n is 8,000 over 2 into a That is 1 plus the last one, which is also 8,000. So that was it. Using your calculator here, let us see what you're going to have. 8,000 over what? Over 2. That's into 1 plus 8,000. All right. And this is going to give us 30. This is actually 32 million and 4. All right. 32 million and 4,000. Like this. Okay. So this is the sum of all terms, 8,000 of them combined. All of them here, they are combined. This is all terms, sum of what? Of all terms. Okay. Then we consider powers of 6 from 1 up to 8,000 powers of 6. So powers of 6, do not worry, guys, when I talk about powers of 6, they increase like rapidly. So 8,000 is actually a smaller value that you can be worried to say powers of 6. How can I find all powers of 6? You can find all powers of 6. They are very small, guys, right? 8,000 is a very small value, that one, for powers of what? For powers of 6. So that's starting from what? 1 powers of 6, 6 to the power of what? 1. We cannot consider a 0 there. We consider powers of 6 like 6 to the power of 1, 2, 3, and so on. All right, that will be the powers of what? Of 6 when they are removed to the power of 1, which is 6, to the power of 2, to the power of 3, and so on and so on. So 6 to the power of 1 is going to give us a 6. To the power of 2, that is a 36. To the power of 3, that was going to give us 216. To the power of 4, yes, do not worry, guys. Your calculator can simplify this. It's just a small value, this one. 1,296. Then to the power of what? 5, and so on and so on, right? So that's to the power of 5. Let us see what you're going to have to the power of 5 here. That's 7,776, almost at 8,000, meaning to say to the power of 6 cannot work. 6 to the power of 6 is actually outside. It's now 46,000. So you see, guys, these are the only powers of 6 that we are going to have from the sequence that we are given from 1 up to what? 1 up to 8,000. Right? From that 1 up to 80,000, those are the powers of 6 that you're going to have. So they are saying if the sum is removed of these powers, all right, if the sum is what is removed of these powers, what are we going to have? That is the consideration. If the sum is what is removed, what are we going to have? So let's consider now the sum of these. Guys, whether here you do not know the sequence, I mean this sequence, like these terms, they are forming which sequence, whether you know or not, you can simply add. These are how many terms? 1, 2, 3, 4, 5. So you can simply add, guys, sum of what? 5 terms of these powers of 6. All right, there are 5 of them. All right, sorry for that. So here you can simply add, but do not worry, I'm just going to also consider to say what is actually the sequence that is being formed. So for this sum of what? Powers of 6, we can simply add. There are how many terms? That is equal to 1. They said 5. That's S5. So simply add 6 plus 36 plus 216 plus 1,296 plus 7,776. Simply add these. All right, that was going to give us 9,330. That's the sum. Then you subtract from these 8,000 the sum of all terms. Then you're done. Or you can consider to say, all right, what is the sequence that is formed? Some of you guys will be like, what is the sequence formed from there, from this? This is, this cannot be arithmetic. This is actually geometric. Here, you're going to consider powers of 6, 36 divided by 6. That's a 6. Is that so? All right. Then 216 divided by 36, that's also a 6. 216 divided by 36, that's also a 6. So that's a geometric where we have got what? A constant ratio between these two, between these terms. We've got a constant ratio. So if it is a geometric, the sum of terms is going to be given by a r to the exponent of n over what? R minus 1. So our a, that's considering the sum of momentums 1, 2, 3, 4, 5. There are 5 of them, is equal to a, our first term, 6, times our r is what? 6 to the exponent of n, 5 terms, minus 1 over what? R minus 1, that's 6 minus 1. So still, you are going to obtain that same answer that we obtained before. All right, let us just verify that we must obtain same answers there. All right, 6 to the exponent of 5 minus 1, and here we're going to have over 6 minus what? 6 minus 1. So as we can see, we obtain the same answer, 9,330, the one that I obtained by simply adding these. There are few terms, guys, that you can simply add on your calculator. All right. So that is the sum of the powers of 6, the ones that were being what? Removed. Remember, this were being removed from our sequence. So if they were removed, therefore the sum of the remaining terms was going to be what? All terms, 8,000 of them combined gave us what? 32 million and what? And 4,000, like this. Minus the powers of 6, their sum from what we obtained. We obtained what? We obtained 9,330. So simply subtract that one from those, you are done. Because they are being what? They are being removed, those powers of 6, they are being removed. So simply subtract that. So that was going to give us 31,994,670, like that. All right. So that is the sum of what was going to remain. All right. So you see, guys, they'll be playing around with you for marks. They'll be playing around, playing around, playing around. They want you to understand all the basics, all right? You must understand all the basics as an individual, all right? Number 4, we are given 4.1. Michelle notices the following about number of black tiles and number of white tiles. So that's what we are given. The figure 1, there is 1 black tile, all right? But for the white tiles, they are 3 times 1 plus 2. Like she used these formulas to calculate them, but there's 1, 2, 3, 4, 5 of them, all right? Then here, there are 2 black, but white, 1, 2, 3, 4, 5, 6, 7. There are 7 of them. Yes, we are obtaining the same 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 plus 0, that's actually a 9. So this formula was actually correct because it corresponds, but it is a formula that she formulated. She notices that. But if you check the black, they are just increasing as the figure. With the figure, figure 1 is 1, fig 2 is 2, fig 3, they are 3. In figure 4, they are 4. The white tiles are the ones that needs a formula, but the black, they are just like that. Meaning to say for figure 7, there will be 7 black tiles that you're going to have there. But the white, we have to consider according to what? According to the formula. And here, if we check according to this formula, it is 3 that is constant throughout. Then these numbers, it is like T1, 1, 2, 3, 4, 5, 6. All right. So that is the condition. But here we started with a 2. All right. 1, 0. So you have to note like what is happening here to say 2, 1, 0, like that. All right. So if we are to check properly, it is just like the first term, this is T1. So it is just like 2 minus n minus 1 to obtain these 2, where n is 1. So it will be 2 minus 0, which is what? 2. If we move on to the second one, it is going to be 2 minus our n is what? 2. So that's 2 minus 1. It's going to be 2 minus what? 1, which is 1. So for this one. For the third one, our n is going to be 3. So 3 minus 1, that's a 2. So 2 minus 2, that's what? That's a 0. So that's why you see a 0. So that's actually like something that was happening there. It's something that you can study. All right. So anyways, let's see. 4.11, if this pattern continues as above, write down the rule for the number of white tiles if the figure has 17 black tiles. 17. So if the figure has got 17, remember the black tiles, they correspond like figure 1 black, figure 2 black. So if we are talking about 17 black tiles in this case, it means the corresponding figure was what? Was figure 17. So figure 17 here is going to be written as what? As T17. T1, T2, and so on, which is equal to 3 times, remember this corresponds to the term that you are working with. 1, this is 1, 2, this is 2, this is 3, and so on. So as we are referring to what? 17. So that's 3 times 17. All right, then here, as I obtained from this formula, it's going to be 2 minus our n is what? 17. So that's 17 minus 1. So it's going to be 2 minus 17 minus 1 is what? 17 minus 1 is 16. And 2 minus 16 is what? Minus 14. So that was going to be a negative 14 there. You can study that. It is something that you can study to see what was happening. You can also study it in another way. This part here, you can obtain it in many ways that you can actually have at the end, is that this is the idea that you're going to have at the end from each and every part. Each and every part. Or someone can simply say, from each and every part, we are subtracting this. From each and every part, we are subtracting like 1 minus 3, that is a 2. 2, all right? 1 minus, I mean like 3 minus, but the way that I'm subtracting, guys, does not make sense, isn't it? 3 minus 1, that's a 2. 3 minus 2, that's a 1. 3 minus 3, that's a 0. 3 minus this, that's minus 1. So for our case, 3 minus 17, because these ones, it is something that was already there. So 3 minus 17, you know, it's going to be negative 14. So you can also study it that way. This is something that you can study to see what was exactly happening. All right? She noticed it is from what? From studying. She notices this. So also as an individual, try to study that pattern to see what she noticed. It was taken from what, actually? All right. So anyways, I don't know, guys, the way that you studied that, but at the end, you must obtain what? Same answers at the end. All right. Write down the nth term of the number of white tiles. All right. Around any black tiles. So remember, any black tiles, they correspond to what? Figure n. So if it is figure n, what is going to be the nth term of the white tail? Here we're now talking about the white tails now to say this was our T1, the first term, T1 giving us a 5, T2 giving us a 7. How many are they? How many white tails we have? How many? So that is what we are considering. So we can simply work with those terms, guys. What are they forming? That's 4.12. All right, let us just save it here, 4.12. So for white tiles, this is what we're going to have. Our Tn is from these terms, all right? The sum, like how many of them are there for the first one? There are 5 white tiles. For the second one, there are 7, 9, and so on and so on. What type of a sequence are we forming? This is actually an arithmetic, all right? The constant difference, 7 minus 5, that's a 2. 9 minus 7, that's a 2. So you can see that we've got what? An arithmetic here. So our Tn is going to be taken from an arithmetic in our case, where our Tn is equal to a plus n minus 1 times what? Times d. That was the consideration, guys. You consider that, all right? Tn, a plus n minus 1 times d. So that's our Tn, our a, the first term is 5 plus n minus 1 times d, which is what? Which is 2. So that's it. 5 plus 2 times n, that's going to be 2n, times negative 1, that's negative 2. So here we're going to obtain 2n, 5 minus 2, that's a positive 3. All right, so that is what you were going to have at the end, 2n plus what? Plus 3. This is for the white tiles, all right? Just like that. Then on 4.13, how many black and white tiles will Michelle have in total up to the 25th pattern? In total, that's the sum. That's the sum. So you have to add for the blacks. All right. So for the blacks, guys, we are saying figure 1 has got 1, figure 2 has got 2, figure 3 has got. So you're supposed to add. So up to the 25th, you're going to add in that manner to say how many are we going to have for each. If they are 6, if they are 7, up to the 25th, you add those. But if you are to consider what type of series or are we going to obtain from the black as we had on the white? This is 1, this is 2, this is 3, this is 4, this is 5, and so on. This is an arithmetic where we have got our constant difference as what? As 1. Just an arithmetic, guys, where our constant difference is what? Is 1. So you can find the sum of terms when you are given 25 of them. For these blacks, if you are given 25 of them, we can find the sum. Where can I just write it? All right, let me just do it here. You understand me very soon. So that's 4.13. All right, that's 4.13. So as for the blacks, guys, these ones, they're easy because you just add 1, 2, and so on and so on. So they're being taken up to the what? Up to the 25th, all right? Up to 25. So there you have the first term, which is your A, and the last term, which is your L. So you can find the sum from there, n over 2 into A plus L, because you're forming a what? An arithmetic. So the blacks, how many are they? 25. So it's the sum of 25 terms. That's 25 over 2 into A. Your A is the first term, 1, plus A plus L, which is the last term, 25. 1 plus what? 25. All right. So that was the easier part of those blacks because they are forming an arithmetic, and that's a difference of 1 throughout. 1. If it is 1, it's 1. It's 2. Or you can simply add 1 plus 1 plus 1 plus 2 plus 3 plus 4 up to what? Up to 25. We are still going to obtain the same answer, which is 300 and what? 325 from there. So that's the sum of what? 25 of the blacks that we have. What about the white? Because on this part, what will be the sum for the white? Remember the white here, we say they are also forming what? They are also forming an arithmetic. If you are to consider here, from what we had, these are the white tiles. They are also forming an arithmetic with a constant difference of 2. But there, we cannot say our T1 is 1. Take note, if our T1, from what we had, it was 5. The terms, it was 5, 7. So we cannot say that 25 is the last term. So we cannot use this formula. This formula is used when you know the first and the last. Here we knew it because of the guys. We are talking about 1, 2, counting 1, 2, 3, 4, 5, up to 25. So you can know that the first one is 1, the last one is what? 25. But here, guys, look at the way that you are counting 5, 7, 9. Yes, you can do that up to the last, but it will be easier for you to just use this formula now for this one, the sum of terms of what? An arithmetic in that manner. It will be easier. All right. So for white what? For white tiles, we need their sum of terms. So their Sn is going to be n over 2, 2a plus what? N minus 1 times d. That will be the easier one. How many terms are we talking about that are white in total? Remember, what we are being told about these is that they are corresponding to each other and they have up to the 25th pattern. Up to the 25th pattern. So this is the same consideration that we are going to have in our case to say up to the 25th pattern, what will be the total number of tiles? Remember, these tiles, guys, they are corresponding to each other. The first block, it has white and black. The second, it has white and black. So up to figure 25, guys, up to this 25th pattern, it will be white, black, white, black, white, black, white. So they are also part of the number of terms, the 25, because it's the same figure that consists of the white, that also consists of what? Of the black. So that's going to be S25 again. And that's 25 over 2 into what? 2 times A. For the white tiles, our A is what? Our A is 5 plus N 25 again minus 1 times D. The constant difference there is what? Is 2. So that is what you're going to have for the white tiles. So be very careful about that 25 because it is the same pattern. I mean, it is the same block that has got black, that has got also white. So where the blacks are found, they are found from those 25 that are being counted, the same as the white from each block, first, second, up to 25 of them. Then we can simply combine our answers. All right, so let's hope, guys, my explanation is going to be understandable from this part because, yeah, most of you are going to have a question, but that is what you're going to have at the end. So how many are we going to have now in total? So we separated black and white, but they are from the same, like this block 1, it consists of black and white. Block 2, it is black and white. So there will be 25 added together. But as they are added, we just separated to say, let the black be on their own. Let these ones that are white be on their own. That is what we simply had. So all in all, the total number of tiles, the total tiles will be what? Remember, for those ones that are black, 325. These ones that are white, 700 and what? 25. We add. That is going to give us 1,000 and what? 1,050 in total. So that was the consideration of our question 4.13. So you see, guys, yes, we do play around with these typical questions. Yes, sometimes they want to stretch you further. Yeah, they can stretch you further. Do revision, guys. Do revise as many questions as you can. You see that they do repeat. All right. Which term of this series, all right, this one is another question on its own, different from what we had, all right? Which term of this series that we are given here, 19, 18, and 1 over 5, and this is the first negative term, all right? Whether I know the type of series that is being formed, it's geometric or it's arithmetic, whether I know or I do not know, as long I'm to consider which term, I'm talking about Tn of that. And when I'm to consider that is negative, it simply means my Tn has to be less than 0. That is for it to be what? Negative. It must be less than 0. So now is Tn of what? Is it of an arithmetic? Is it of a geometric? Then you consider what you're given here. What are we forming? All right, can this be arithmetic? Right, yes, it can be arithmetic, not geometric, but arithmetic. Let's consider subtracting these terms, T2 minus T1, all right? Our calculator, T2, that's 18 and 1 over what? 1 over 5. Minus what? Minus 19. That's negative 4 over 5. All right. Then T3 minus T2. All right. That's 17. All right. Let us just put it somewhere here. So it's going to be a minus here, but it's going to be 17 and 2 over 5 subtracting that. All right. 17. Why is it not giving me that fraction? All right, so which means I have to start again. All right, let me just redo it. 17 and what? 2 over 5. 2 over 5 minus 18. All right, minus 18 and what? 1 over 5. This is going to give us negative 4 over 5. So guys, we can see that this is an arithmetic where we've got what? The constant difference. So the Tn that we are referring to is of an arithmetic. All right, that's an arithmetic, which we do understand it is a plus what? N minus 1 times d. So that's our Tn is going to be a, the first term, 19 plus n minus 1. All right, times d. Our d is the constant difference of negative 4 over 5. So let's find our Tn, that's 19. Multiply by negative 4 over 5 here, that's negative 4 over 5n. Negative 4 over 5 times negative 1, that was going to be positive 4 over 5. So that's our Tn is going to be negative 4 over 5n, then collecting the like terms, 19 and what? 4 over 5. Add them together. 19 plus what? 4 over 5. This was going to give us 19 and 4 over 5. All right. Or you can write it as 99 over 5. So that's plus 99 over what? Over 5. That's our Tn. But remember, the condition is that our Tn here is supposed to be what? Less than 0 and to be a negative. So you take that Tn, then solve. All right? Negative 4 over 5n plus 99 over 5 is supposed to be what? Less than 0. So let us solve for n. All right? We can take this to the other side. It's going to be a negative. Negative 4 over 5n is less than what? All right, taking the negative to the other side is going to be a positive. So, sorry, a positive to the other side is going to be a negative, so negative 99 over 5. So here, guys, we can simply see what is happening in terms of the 5 in the what? The 5 that we have in the denominator. This one and this one can simply cancel. You have got negative 4n less than what? Negative 99. So to find the value of n, we're going to divide by negative 4 by negative 4. Dividing by negative reverses the inequality sign. Remember, it reverses the inequality sign. So it is going to be greater than, all right, negative, negative cancels. So that's 99 over what? Over 4. But 99 over 4 is same as what? As a decimal. 99 over 4 is the same as 24,75. So it's greater than 24,75, all right? 24,75 like this. So if this is the idea or if this is the concept, guys, from what we are having to say our Tn, this one that we had is less than what? Is less than 0. So which term now is the first? Which term is the first negative? So the first negative from there, we are talking about a number. Our n is supposed to be something that is greater than 24,75. According to this 24,75, 25, 26. So the next will be what? 25. So n is supposed to be equal to what? 25. That's the first one. For numbers that are greater than 24,75, the first integer that we have there is what? 25. So we're talking about number of terms. We're talking about what? It must be a positive whole number that you are referring to. So the first negative term, the first negative term in our case is going to be what? T25. That will be negative. When n is what? When n is 25, we're talking about what? We are referring to T25. That is the first one to be a negative. So that is how they simply play around with these questions. Just try to go through the basics, all right? All the basics. It is very, very important. So this is what we needed for 5 marks on question 4.2. All right, that is what we actually needed in order for us to obtain those marks. So moving on to question number 5, where we are given the graphs of f of x and also the graph of gx. They are being sketched below. All right, so this is the sketch that we are given. So make sure, guys, you download the question paper so that you can properly see the questions and also the diagrams, all right? So from this information, our f of x is a quadratic function or a parabola, all right? Then our gx being what? A linear. So there we have got a linear are being sketched, and the information was given that A and B are the x-intercepts of f, as we can see here. A and what? B. That is the x-intercepts of what? F. F, and A is also a point which is on what? On our G. All right, that is what we can see. Then C is what? The y-intercept. C is the y-intercept for F and G. All right, this point C, you can see that it affects both F and G. All right, then D is the turning point. All right, so we've got our turning point here. Then the point E is given as minus 6p. All right, so that was our information. Let us see how can we attempt this question. That was the whole of our question number 5. You're having 18 marks from that diagram that we are given. All right, let us try to figure out. 5.1, write down the value of what? The value of P. That is 1 mark for that. P is actually found from our f of x. So I'm just gonna rewrite my f of x here so that you can properly see it. Our f of x is given as x squared plus 2x minus 8. All right, remember, this is your f of x. And from this, we can see that to find, all right, for 5.1, to find the value of P, we can find it from the point E, all right? That's from what? From point E. From E, we are given this as negative 6p, all right? That's the x value and the y value. And this point E lies on what? On f of x. So if it lies on f of x, it means when x is what? Negative 6, we are going to find the value of p. All right, that's simply f of what? Negative 6. In place of x, substitute negative what? Negative 6 in this. All right, so that was going to be negative 6 squared plus 2 times x. That's 2 times our x is what? Negative 6 minus 8. All right, so this is what you're going to have at the end. So simplifying this, that was going to give us 18. All right, we are going to simplify this. Negative 6, we square this one plus 2 into a negative 6 again, minus 8. That was going to give us a positive what? A positive 16. So that was the value of P from what we are given. So moving on to 5.2, we are given now to determine the coordinates of A and B. All right, that was for 4 marks. All right, let us consider this. All right, so here we said this is 16. So to find the values of A and B, we can see that, I mean, the coordinates here of A and B, we can see that A and B are the x-intercepts of what? Of f, of this function f. So meaning to say, for this, in the x-axis, we do understand y is equal to 0. So simply, our f of x is supposed to be equal to what? Is supposed to be equal to 0 in order for us to determine the coordinates of A and B from this concept. All right, so just take your f of x, x squared, plus 2x minus 8. That is supposed to give us what? A 0 there. So we can simply factorize. Yes, we can use our quadratic formula, but simply factorize. The coefficient of x squared is 1. So that was going to give us x and x here, considering the factors of what? Negative 8 in this case. We are considering negative 8, which will give us what? A positive 2. All right, so factors of negative 8, there are so many factors, guys, for negative 8. Negative 8 and 1, 8 and negative 1. All right, 4 and negative 2. Negative 4 and what? Negative 4 and 2. All these, they are factors of what? Of negative 8, but we need a condition where we can add and obtain a positive 2, that is on 4 and what? Minus 2. So that's 4 minus 2. So each of these must be equal to 0. So 4 is going to give us a negative 4, or x is equal to the minus 2 is going to give us what? A positive there. All right, so that is what we have. So from these guys, minus from the origin, that's the value that is affecting the point A. That's at negative what? 4. B to the positive is the one that is going to be positive 2. All right, so therefore, meaning to say our point A is negative 4 or 0. Remember, in the x-axis, y is equal to what? Y is equal to 0. And our point B, that's at 2. So that's 2, 0. Our x is 2 and y will be what? Y is going to be 0 there. All right, so that was it for the coordinates of these 2 points A and what? A and B. Now let us consider 5.3. Determine the coordinates of what? D. Remember, D is what? The turning point. So it follows that, guys, to determine the coordinates of D being the turning point, there are actually so many ways that we can use. All right, we can actually apply so many ways. We can use the derivative concept to find the x value at that point. All right, since D represents the turning point. At the turning point, all right, at the turning point, it follows that x is equal to the average of these x values for the roots of the function or the x-intercepts. All right, x at A and x at B. So it's the average x at A plus x at B over 2. You can simply find your x value that way. So minus 4 plus 2. All right, so that is the concept, minus 4 plus 2 over 2. And that was going to give us negative 2 over 2, which is what? Negative 1. So meaning to say for that D that we are referring to, the x value corresponding there is what? Negative 1. It is corresponding when our x is negative 1. There are so many ways that you can actually consider at the turning point. Remember, at the turning point, it also follows that the value of x is equal to minus b over 2a. All right, where our b is what? 2. So it's minus 2 over 2 times a, the coefficient of x squared. So that's 2 times 1. All right, that is the consideration that we also have when we are to consider what? When we are to consider the turning point. All right, so here our x value, sorry, our value of a, sorry for that. I think it's just my network here. All right, let me see. All right, guys, see, this is just affecting when I want to present my work. So that is a positive 1 here. And our x was going to be negative 2 over 2, which is what? Which is negative 1. Or you can also use the derivative concept. There are so many ways that you can actually use. The first derivative of x with respect to x is supposed to be equal to 0 at the turning point. So you can find the first derivative with respect to x. That was going to be 2x plus what? Plus 2. All right, so 2x plus 2 is supposed to be equal to 0. So that's our 2x. 2 is going to be negative 2 divided by 2 by 2. So that's going to give us the value of x from there, which is what? Negative 1. So as we can see, guys, all these is to find the value of x at the turning point any way that you understand of the ones that I've listed. All right, there are so many ways that you can actually use, but what we can see that at the turning point our x is equal to what? Negative 1. So to find the value of y, you can substitute back into our original function. So that is f of what? Negative 1. When x is negative 1, substitute that. So that's negative 1 squared plus 2 times what? Negative 1 minus 8. So simplifying this, that was gonna give us a negative 9. All right? That is negative 1 squared plus 2 into negative 1, all right, minus 8, like this. And that was going to give us negative 9. So that's the value of y at the turning point. So therefore, our point D is going to be given as x is what? X is negative 1. The y value is what? Is negative 9. So that is the condition, guys. You substitute that value of y, which is what? Negative 9, like that. So that is how they can actually ask these typical questions. So you just have to be very careful. So that's our turning point, just in case we are going to need this. It's negative 1, negative what? Negative 9. All right, so let us consider another part from our question here. Let us consider that's 5.4. Determine the values of M and what? C. M and C for 2 marks. M and C are from GX. If we are to consider our linear function that we are given, that is where we have got M and what? M and C. So that's from what? From our GX, all right? So meaning to say on 5.4, to determine the value of M and C, we are going to take that one from what? Our GX, where our GX is given as mx plus what? Mx plus c. M is the gradient and c is the y-intercept. All right. So to find the gradient of the line gx, this is our gx, we need 2 points. So far we have got point A. Remember, it is the x-intercept of both lines. So we have got point A, negative 4, 0 there. All right. Then another point that we can have on GX is C, which is what? The y-intercept. Remember, it is the y-intercept of both F and what? F and G. So from F, we can find the y-intercept as x is equal to 0, y is equal to what? Negative 8. That's the y-intercept. We can find it from our f of x. So that's the point C is going to be given as what? 0 minus 8. Remember, x is 0 there. Then y is what? Negative 8. So that is, we can obtain the gradient from this, all right? So this is y1, x2, y2. So our gradient representing m is equal to y2 minus y1 over x2 minus x1. So substituting y2, that's negative 8, minus y1, which is negative 4, over x2, that is what? 0 here, minus x1. All right. What did I just do here? This is y1. All right. You see this dragging thing now is affecting my pace. All right. X1 is the one that is what? Minus 4. So at the end, you're going to obtain minus 8, 0 minus minus 4. That is going to be positive. And this will give us what? a negative what? A negative 2 from what we are having. All right. So this is what we're going to have. This is our x2. All right. This point, minus 4, 0. All right. That's our x1 minus 4, 0. And this is 0 minus 8. So that was going to be that one, negative 2. All right. So that's our m is what? Negative 2. Then the value of c is the y-intercept. C is the y-intercept. So remember, this line crosses the y-axis at what? At point C at what? Negative 8. So our C is going to be what? Minus 8, the y-intercept. So that was it, meaning to say our line was going to be given as y is equal to what? M minus 2x plus C minus 8, all right? But there we're asking you M and what? C, the values of M, that is the values of M and C. So that was it. Then in this case, we are given 5.5, determine the equation of the tangent to F at what? At point C. The tangent to F, all right, at what? At point C. All right, remember a tangent, all right, remember the tangent concept. All right, if we are given that there is a tangent on what? On F at point C, something like this. All right. So the question is to determine the equation. What is it that we are going to take from point C? We have got the coordinate there. So that's, we have got the point C. All right. That's 5.5. The coordinate of point C is already given. The y-intercept, remember, that's minus 8. So that's 0 minus 8. That's what we can take from that point. But it is a tangent to what? To F. So if it is a tangent to F, we do understand that the gradient, which is the first derivative of our f of x, must be equal to m, which is the gradient of the tangent at this point at 0 minus 8, meaning to say at a condition where x is equal to what? At x is equal to 0. At this point, that's x is equal to what? 0. That's the gradient. Because we need the equation, remember. So in order for us to obtain that equation, y is equal to mx plus c, we need the gradient, m. So that m, this one, we are going to obtain it from the first derivative, where x is what? Where x is 0, from point C. So what is the first derivative in our case? The first derivative with respect to x from our f of x, remember, drop the power, subtract 1. It was going to give us 2x plus 2. This is a linear, so we're just going to take the coefficient of x. A constant gives us a 0, remember, our derivative. So you're going to have 2x plus 2. But I'm saying that the numerical value of our gradient of this tangent that we are referring is going to be at a condition where x is what? Where x is 0. So it was going to be 2 times the value of x, which is 0 plus what? 2. And that was going to give us what? A positive 2. So the tangent has a gradient of what? Of 2. And its equation, because it is a straight line, it is supposed to be given as y is equal to mx plus c. So therefore, y is equal to m, that's our 2, the gradient. So that's 2x plus our c. C is the y-intercept at minus 8, the line, that tangent crosses the y-axis at what? At negative 8. That is not going to change. It is going to cross at what? At negative 8. So therefore, that is going to be our equation at the end. All right, that is what we are going to have as the equation of what? As the equation of the tangent from there. All right, so it was a little bit direct, from what we can see. That is a direct question. Then 5.6, the range for minus f of x. Write down the range for what? Minus f of x. So take note here, f of x is the original function, but we need minus f of x. Minus f of x, it means we are simply referring to a reflection in the x-axis, all right? If you are given your f of x like this, if you reflect it minus f of x, the y values will just change like this. So this will be the graph of y is equal to what? Minus f of x. So remember that the range, when we are referring to the range, we are referring to the y values. So the original function, our f of x, was at, the turning point was at -1, -9. This is where we had our turning point. So what about for y is equal to minus f of x? Its turning point, the x value is not going to change. It's going to remain as it is. So the x value is going to be -1, but the y value will be multiplied by a negative. So it's going to be negative times this negative, that will be what? A +9. So the turning point of the graph of y is equal to minus f of x is going to be at -1, 9. And this graph that we are referring to, it is what? Concave down, meaning to say it is limited at that point where y is equal to 9. So therefore, its range will be y is less than or equal to what? Less than or equal to 9, just like that. So that was the range of what? Y is equal to minus f of x. Or you can work with the range of what? Y is equal to f of x. Y is equal to f of x. Its range was y is what? Values, these are limited to -9 going up. So y is greater than or equal to what? -9. So when you are referring to minus f of x, you simply multiply by negative, you multiply by negative. Remember that concept. So meaning to say, sorry, minus y this one. You multiply by this negative here. So to get rid of that negative, you're going to divide by what? Divide by negative like this. So y, the moment we divide by negative, inequality sign reverses. The negative cancels. That will be what? A 9. So many ways that you can actually use to determine that range for minus f of x is simply from the original function, then reflect it. All right. 5.7, for which values of x will f of x minus gx be greater than 0? All right, for 2 marks. All right, let's see. Let's see what we have there. F of x minus what? Minus gx. So if we are to consider this here, I talked about these effects that can happen on what? On f of x and any other graph actually that you'll be given. So if you check, there's a playlist that I created. So make sure that you go through that, understand all the basics. All right, but that was our 5.7. They want a condition where f of x minus gx is greater than a 0. Since there is nothing here, let us take this minus gx to the right-hand side so that it's going to be a positive, and it will be easier for us to even solve because it will be greater than gx. F of x will be greater than gx, which is a condition that is well known to us. We simply need a condition where f of x is above, greater than gx. It must be above what? Above gx, on top of gx from the graph. So what is needed in our case are the critical values where we can compare our graph to say this one is above or not. So the critical values in this case will be the points of intersection. All right, the points of what? Of intersection. The points of intersection. Those are the critical values. So at the points of intersection, we are referring here at this point, -4. So that's a critical value that you're going to need at the point of intersection, where x is what? -4. Another critical value, point of intersection at C. What is the x value? So this becomes what? our critical value again. So the critical values is -4, this value of x. That's at what? X is -4, and this one for the y-axis, x is equal to what? X is equal to 0. Those are the critical values. So let us compare. Where is it that our f of x is above gx, is on top of gx, is positive, more positive to gx? So this is our f of x, remember? That's our f of x. All right. So from the critical value, -4, let's start with this -4. All right. Comparing these values on the left side, -5, -6, and so on, we can see that our f of x is above. This is our f of x. Look where it is. It is on top of gx. Gx is below f of x. F of x is on top. So we actually need that. So this is the condition that is required where x is less than what? -4. So that one is part of our solution. All right. Let us move on. Between the critical values, we've got -4 and what? And 0. So in between, you take it in between as it is, in between -4 and 0, in between. What is happening? If we check, this is our f of x. Our f of x is now found below g, below this gx. It is below, not above. It is found below. This is our g. Look, it is on top of what? F of x. So we do not need this. F of x has to be above, but is now below that. So this is not appropriate. So we're not going to have a solution there. We move on from 0 going to the up to infinity. What is happening from 0 at the point of intersection at C? If we check, our f of x is now above. This one is on top of g. Look where g is going. F is going up, g going down. So from that point here, we need this condition, from a condition from what? From x is equal to 0 going up to infinity. F of x is now above gx. So that's another solution, or x is supposed to be greater than what? Greater than 0. So we are referring these values from 0 going up. Those values, they are what? Greater than 0. Take note, we do not have an equal to on our question. So do not put that, all right? Do not put that equal to. Just leave it as they are, like this. So that was it. You simply refer to the graph. But if you check, like I said, there's a playlist that I did on how to answer these typical questions, all right? The effects that gonna happen on f of x. So go through that, understand all the basics, all right? Let us move on to 5.8, where we are given, for which values of k will this have no real roots, all right? So here we can simply work out our discriminant concept, guys. All right, that's on 5.8. There's no need of a graph there. All right, if we do not have real roots, it means no real root. That's non-real. All right, non-real roots. For non-real roots, we do understand that our delta has to be what? Less than 0, where our delta is given as what? B squared minus 4AC. That is equal to B. That's A, B, C. So B, the coefficient of x, 2 squared minus 4 times A, the coefficient of x squared. Our constant is what? Our constant is K. We can find our delta from there. So that's 4 minus 4 times 1 times K. That's 4K. But we are saying this has to be what? Less than 0. So from there, we can find the values of what? K. For which values of K? Our delta, this part, 4 minus 4k has to be less than what? Has to be less than 0. Then solve for k. All right. So minus 4. All right. So minus 4k is less than, if we take 4 to the other side, is going to be a negative. So that's 0 minus 4, which is a -4. Divide by -4 by a negative. Remember, the moment you divide by a negative, the inequality sign here reverses, all right? Or it changes. So meaning to say it's going to be greater than 1, all right? So that's k is what? k is greater than 1 from that information that we have obtained. So that was it for 18 marks on this question. All right. So you see, guys, they are going to ask such typical questions. Just make sure you go through all the basics, understand all the basics. That is why we've got introductions. Go through the introduction of each and every topic. It is very, very important that you go through those introductions. All right. So on question number 6, we are given hx, which is 6 over x minus 2 minus 1. All right. So there we are going to be working with our hyperbola. 6.1, write down the equations of what? The asymptotes of h. So from the asymptotes, we know that from x minus 2, we can determine our asymptote. The x minus 2 has to be equal to 0. So x will end up being a positive 2 on the other side. Then the y value is not affected. Y is equal to what? Negative 1. So those are the equations. Then 6.2, determine the coordinates of the x and y intercepts of hx. So that's from our hx, all right? 6.2, let us consider our x-intercept. That's a condition where y is equal to 0. So simply put a 0 there, then solve for x. All right, so let us solve for x. We can take the negative 1 to the other side is going to be a positive 1 here. So that's 1 is equal to 6 over x minus 2. Over 1, we can cross multiply. 1 is going to multiply x minus 2. So that's x minus 2, 1 times 6, that's 6. So x is equal to what? Negative 2 to the other side, that's a positive 2. So that is going to give us what? 8. So thus we have got the x-intercept in that case will be simply when x is equal to 8, y is equal to 0. All right. So that's our x-intercept. All right. Moving on to the y-intercept. Y-intercept, simply substitute x being what? Being equal to 0. So that's it for the y-intercept. X is equal to 0 there. So place a 0 in place of x. So y is equal to 6 over 0 minus 2 minus 1. So that was going to give us the value of y there, 6 over 0 minus 2. Then we're going to subtract 1. All right, so that's a negative 4. All right, so that's it. The y-intercept, that's 0 minus 4 from uh, our given function. All right, then from here, from the given graph, I mean, we can have those x and y intercept. Then 6.3, sketch the graph of hx. Clearly show the intercepts with the axis and asymptotes, if any. If we have these, let us represent them on our graph. All right, so remember we've got the x-intercept, the y-intercept, and the asymptote. The first part here was of what? The asymptotes. So we can play around with this information to have our sketch. All right, so that's our 6.3. We can easily just have a simpler sketch here. All right, let's see. We can just have something that is going to help us to have this sketch. All right. So let us say we have got something like this. All right, all right. I just hope we'll be able to finish up, guys, without any like disturbances, because you see, guys, what's happening is that like, I don't know, is the network or it is the work of what? It is the work of, I don't know. I don't even know, guys. So this is something like this, all right? Let us have also our x-intercept. All right, so here just a sketch, guys. Let us just say we've got 1, 2, 3. This is 2, 3, 4, 5, 6, 7, 8, and so on. All right, so we're just gonna need to adjust also this a little bit. All right, so that'll be 8, 9, and so on. -1, -2. All right, -1, -2, -3, -4. 1, 2. All right, 2, 3, 4, 5, something like this. So that is your x-axis and this is your y-axis. So we have got the asymptotes here where x is what? Where x is equal to 2. So x is equal to 2. That's we're going to have our asymptote. All right, passing through this, just going to have x is equal to 2 passing through this 2. All right, it's an asymptote. So our graph cannot cross or it cannot pass this line of what? Of x is equal to 2 and y is equal to -1. That's y is equal to -1 somewhere there. All right. So our graph is limited to these asymptotes. All right. That's y is equal to -1. But there is, all right, from this, the shape from our A, we do understand that A, there is a positive. So if our A is a positive, it means from our asymptotes, the shape is going to be like this. All right, so for the shape there, which we can use with these intercepts. X-intercept at what? At +8. So indicate that at +8. Then the Y-intercept, that's -4, all right? Remember, it was a -4. So this is your y-intercept, all right? So from this information, remember the sketch must have something like this. So this is going to be within this region, all right? We're going to have our shape affected within that region. So something like this, all right? Then within this region, we're going to have our shape like this, all right? So that is the consideration passing through the y-intercept at -4, all right? That's another piece representing our graph of what? Our graph of h. You can put h here or put here. It's not a problem. And this is the intersection of those asymptotes where x is what? Where x is 2 and y is what? Y is -1. All right, so that was it. From there, you are being asked to determine the values of x for which hx is less than 0. And x is taken from 0 to infinite. From 0 to infinite, that's our 6.4 from that graph. All right, take note the interval that we are given from 0 up to +infinite. That's where our x has to be taken from. So we are going to consider this part of our graph. That is limited to the right side of our x-axis. This side is not to be considered, even if it satisfies the condition that we are given that hx is what? Hx is less than 0. Even if it satisfies that, we cannot take it because our x has to be taken from 0 to +infinite. So we are limited from the y-axis going this side. So where is it that our hx is less than 0, below the x-axis, all right? So we are looking into the x-axis. This is our hx. From here up to 8, it was above the x-axis. From 8 here, 9, 10, the graph is now below the x-axis. So from that value of x at what? At this point that we are referring, which is what? Which is 8, all right? At this point, our hx is what? Below. It is found below. So meaning to say we must consider that x values from 8, 9, and so on, those values, they are what? They are greater than 8. These ones, 8, 9, and so on. The graph is what? Below. Also, there's this part, I also almost left it between this. Remember, we are taking from x is equal to 0. From 0 to 2, this asymptote in between, our hx is below the x-axis. All right, from 0 to what? To 2 in between. We cannot have 2 because 2 is an what? It's an asymptote. So here, x has to be greater than 0 because x is taken from 0 there, and less than what? Less than 2. All right. So actually x can be equal to 0 because x is starting from what? From 0. So x can be greater than or equal to 0. That's another part where hx is what? Less than 0, where it is below the x-axis. We can see this here. We cannot take this side here because we are told our x is taken from what? From 0 up to infinity. That's why we are limited. Otherwise, this was supposed to be part of our solution from 0 minus 1 minus 2. We're going to take that as part of our solution, but it is limited now from where our x is taken. The interval that x is taken is limiting us, all right? So that was it on this part, all right? We had to consider this section of our 6.4, which was 2 marks and total in all 10 marks on question number 6. Let us move on to question 7. There we are given the graphs of px and its inverse are sketched below. So that is our px here and its inverse. All right. So from there, we are given the point K, which lies on P, all right, and the point S, which lies on its inverse. Then Q is the y-intercept of P here, and R is the x-intercept of what? Of the inverse of P, all right? So with these two graphs, these are the questions that we were given that we need to answer, and all right, and also this part on what? 7.5, all right? So let us see. The first one, 7.1, was to determine the value of what? Of B. So we can easily find the value of B from our px. All right, so that's our 7.1. Remember, our px is given as b to the exponent of x. And there is a point which lies on P. This is our px. There's a point which lies on P, which is what? Which is K. So we can use that point to substitute here. 27 is equal to b to the exponent of x. Our x is what? -3. So thus, we can calculate the value of what? The value of b from there. All right, we can easily determine the value of b from there. Getting rid of this negative, it's simply going to be 1 over b to the exponent of 3. I can cross multiply here. 27b cubed is equal to 1 divided by 27 both sides. All right, divide by 27 both sides so that I obtain b cubed, which is 1 over what? 1 over 27. So now I need to find the value of b. I'm just going to introduce the cube root both sides. So that's our b. The cube root of 1 over 27 is 1 over 3. All right, so our b here was going to be 1 over 3. All right, just like that. Then 7.2, you're given determine the equation, all right, of the inverse of P in the form, all right? So what will be the inverse of that P? From what we are given, take note our Px is given as, all right, so the 7.2, our Px is given as B. Remember, we calculated our B, that was 1 over 3. 1 over 3 to the exponent of x. To find the inverse, you are going to interchange x and y. Remember the concept? So meaning to say this will be x is equal to 1 over 3 to the exponent of y. Then we make y the subject of the formula. All right, we're going to make y the subject. So simply y is equal to what? The logarithm of what? Of x. The x takes a log from an exponential to a log. So y will be the logarithm of x. All right, we have to consider what it is equal to. It is equal to x. So it will be the logarithm of x, the base remains as it is as what? As 1 over 3. So that is the inverse of what you're going to have. Remember this concept, log A base B is equal to C can be also written as A is equal to B to the exponent of C. That's B to the exponent of what? To the exponent of C. Just one other cell. So when you're given from an exponential, rewrite as a log. When you're given a log, change to an exponential. That is the concept. So that's our inverse. And write down, in this case, the coordinates of Q and R, all right? Q is the y-intercept, all right? Q is the y-intercept of what? Of P. So we can easily determine those coordinates because it is what? The y-intercept, all right? That's 7.3. All right, so Q is the y-intercept of what? The y-intercept of P, which is on a condition where x is equal to 0. So y is equal to what? From our Px. Px is 1 over 3 to the exponent of x. So at that point, you raise to the exponent of 0, which is what? Which is going to give us 1. Any number to the power of 0 is what? It's 1. So therefore, Q is... remember y-intercept, where x is what? Where x is 0, y is 1. So that's our Q. Then R, remember that R there is the x-intercept of what? Of the inverse of P. And guys, we do understand what happens. Yes, we can find that by substituting y is equal to 0, but what is the idea? This is a reflection in the line y is equal to what? Y is equal to x, where you simply swap the coordinates. So to find R there, simply swap the coordinates that we have. The y-intercept is the one that changed to be an x-intercept. So you simply swap the x and y value. So that'll be 1, 0. Just swap that. All right. Or you can substitute into that condition here because it is the x-intercept. You solve when y is equal to 0. So x was going to be equal to a third to the exponent of 0, which is what? Which is 1. Simply like that. All right. So many ways that you could have used, actually, that you can use. All right. So that's our 7.3. Then 7.4, for which value or values of x will 7.41 px be greater than 0 but less than or equal to 1. All right. This one, we can simply look it into the graph. Let us consider our graph here. Remember, this is 1. This is also 1. So they need a condition where px, all right, let me just try to rewrite. Guys, please download the question paper so that you properly see these questions, especially when I move along the page like this. They want a condition where px is greater than 0 but less than or equal to 1. Px, that is this graph here, it is greater than 0. It simply means it is found above the x-axis, and that is the condition. As you can see, it is what? Found above the x-axis. But less than or equal to 1, it is limited. Remember, at q, y is equal to 1. It is limited where y is equal to 1. So for which values of x will be that consideration? So you're going to notice that when it is limited where y is equal to 1, it is limited for the values of x here, where y is equal to 1 direct here at what? X is equal to 0 in the y-axis. It is limited from that 0, 1, and so on. If you check from -1, negative, the values of y, they are now greater than what? They are now greater than 1. But we need where values of y are less than 1. This happens from 0, from the values of x, which is 0, going up to infinity there. So that's for values of x that are greater than or equal to what? 0. Remember, the question is asking you on the values of x. So you can test it from the graph where y is equal to 1. We see that x corresponds to 0. So from 0 going this side, the y values, they are decreased. They are going that px is greater than 0 above the x-axis. All right. Then another condition from here is given as the logarithm of x in base of a third is less than -3 on 7.42. Again, we can also use the graph to answer this one because we can see it. This is taken from what? All right, let me just do this. This is taken from the logarithm of x in the base of a third. That's 7.42. If you check, this here is from our inverse. The logarithm, that was the inverse. Remember, that was our inverse. It was the logarithm of x in base of a third. So this is the inverse. They are simply saying the inverse of p is what? Less than -3. This is our inverse, guys. The graph of what? Of the inverse. Where is it found less than what? Less than -3. This is the condition at -3, 27 versus -3. The y value there is what? Is at -3. So we need a condition where the graph, where our graph is less than -3. All right. It's limited at what? At that point where y is -3, x is what? X is 27. So from these values, 27 going this side, we can see that our graph will be what? It's going down. That's being less than. It's less than -3. It's going to be -4, -5, -6. 27, 20 reducing this side. These values, they are greater than -3. The y values, we're going to have -2, -1, 0, 1. They are greater than. But from 27, this value of x at 27, increasing going this side, the y values, they are going to be more negative compared to that -3. That's being less than -3. So it's going to happen for the values of x, which are what? Which are greater than that 27. The values of x has to be what? Greater than 27. From the graph, you can simply look at that. Guys, this one can be taken from the graph, straight from the graph. All right, so that was it on this part. Let us consider another part. Here they are saying on this is now 7.5. All right, so let us consider the other section, which is 7.5. T is a point in the first quadrant where TQ is parallel to the x-axis. TQ parallel to the x-axis. This is our point Q. So whatever that you're going to have is what? Parallel to the x-axis, like this. All right? Parallel to the x-axis. That's where our TQ is from this condition. All right? That is the first condition. The line that we are going to have is parallel to the x-axis. What is the other condition? And TS, the same T, here it's also T, but T to S is parallel to the y-axis. When it is parallel to the y-axis, our TS, this is where we've got our point S. So we can note that from point S parallel to the y-axis like this, it's going to be going up, parallel to the y-axis, going up. So you see that that line, as it is parallel to the y-axis, and this line, as it is parallel to the x-axis, they do meet at what? 90 degrees. That is the consideration. And that where they meet is the point T. Because from S, definitely wherever that we are going to meet with that line that we had before, it will be at T. So that's our ST and that's our QT. So the question is, from this information that we have, this parallel and that, all right, let's consider the question now. I want us to understand this part properly, all right? So our question now is, calculate the area of triangle QTS. So this will form a triangle called QTS. From point Q to S, we can join it like that so that we've got a triangle. That's QTS. And this triangle is a right angle triangle. Remember, I said these two, they meet at 90, a horizontal and a vertical line. So we can actually determine the area of this triangle as to find the area of triangle what? Triangle QTS. It's a right angle triangle, so it's going to be half of the base times the perpendicular height. Our base, That's QT, all right, times the perpendicular height, which is what? Which is TS. So what is the length of QT from Q to T? This length corresponds from 0 here to what? To 27. This is 27. So this is what? The length. So all this part here is 27 units, all right? Then our TS is the length here, this one. We're gonna consider this is a vertical line. So the Y value at T is the same as the Y value at Q. Remember at Q, we said the Y-intercept there is 1. So the Y value at T is what? Is 1. The Y value at S here is what? -3. So TS is going to be the difference, the distance, the Y value at T, which is 1, minus the Y value at S, which is what? -3. So that's the distance. So this will be positive, and that is going to be 4 units. All right. So from T to S, we have got what? 4 units. That is the distance in between T and S. All right. From Q to T, this is 0, guys. This is 27. So difference 27 minus 0, that's what? That's the 27 that we see there. All right. So that is now our area of base times what? Perpendicular height. So the base Q to T, which is 27 units, times TS, which is what? Which is 4 units. That was going to give us the area of the triangle. Can you use a calculator? Oh, half of 4, that's 2. 2 times 27, that is 54 square units. All right, we are referring to area measured in what? In just going to use square units, in literal centimeters, square centimeters, like that. So here we are not given in centimeters or meters. We're just gonna use what? Square units. So that was it on question number 7. Moving on to question number 8, part of our derivatives, all right? So that was part of our derivatives here. All right, the first one, 8.1, determine the first derivative with respect to x from first principles. Take note, from this f of x. All right, so that's our 8.1 from our first principles. All right, so our f of x is given as 3x squared. It's actually 3x squared minus 2. And from the first principles, the formula that we are given from our information sheet, remember it is what? Limit as h approaches to 0 of f of x plus h minus f of x. All right, everything over h. So in our case, we are simply going to find f of x plus h. All right, then substitute into the formula. All right, so let us determine f of x plus h from our f of x. F of x plus h here is going to be given as, in place of x, we're going to put x plus h there. So it's 3 into x plus h squared minus 2. All right, remember on the introduction, guys, I've talked about expansion of this, which is going to give us x squared plus 2xh plus what? H squared. Then subtract 2 from that. Expand the bracket by 3. 3 times this, 3x squared by this, 6xh by this, 3h squared. All right, minus 2. So that's actually our f of x plus h, the one that you're going to need here. So substitute that. There was going to be limit as h approaches to what? As h approaches to 0 of f of x plus h. Just substitute this as it is 3x squared plus 6xh plus 3h squared minus 2. Then we're going to subtract our f of x any expression. So we must open a bracket for that. We must have a bracket for that expression, everything over h. So this is it, guys. With that, you can simplify your limits up to a condition where you get rid of the h in the denominator. Then you can substitute the limit where h is what? Where h is 0. But for now, let us simplify. What can we do here? expand brackets so that we can collect our like terms. 3x squared plus 6xh plus 3h squared minus 2. Then expanding by a negative, that's going to be negative 3x squared, negative times negative 2. 2 is going to be a positive 2. All right, that's a positive 2, everything over h. So with this, we can collect the like terms and actually simplify. There is 3x squared and this minus 3x squared. There is actually going to cancel 3x squared and 3x squared. There is a negative 2 and a positive 2. This will cancel. You remain with this from what we are given. That is going to be our numerator there. So our numerator is going to be 6xh plus 3h squared over what? Over h. Our denominator is still with h. So to get rid of that h in the denominator, it is either I'm going to separate these terms or I can factorize. I can simply separate these terms like this, all right? Everything over h. So this will be 6h plus what? Plus 3h, of which I could have just factorized the h, which is common, because we need to get rid of that h in the denominator. So let's factor the 1 in the numerator here. This is going to give us, if we remove h here, that will be 6x plus 3h. It's going to be 3h squared divided by h, which is what? 3h over what? Over h. So as we can see, guys, these two can what? These two can cancel. The moment you get rid of that h in the denominator, that's where you can substitute the limit where h approaches to 0. Remember, guys, the way that I discussed with you on the introduction. So you were remaining with this 6x plus what? Plus 3h. Let us apply the limit. We no longer have this in the denominator. So where h approaches to 0, it is going to give us what? 6x plus 3 times 0, which is what? Which is 6x. So that's our first derivative with respect to what? With respect to x. It was going to give us 6x at the end, which you can also just prove by using the general rule to see if exactly you were going to obtain 6x from there. So actually it was going to be 6x, drop the power, subtract 1, that's 6x. A constant gives us what? A constant gives us a 0. So truly, that was the answer. That is the answer. All right. Let us consider 8.2.1, where we are given to determine the first derivative, all right, from everything that we have. Determine the first one, the first derivative with respect to x, if f of x is this. So this was just straightforward. We just need to drop the power, subtract 1. So 4 times 3, that's 12. X to the exponent of 3. 4 minus 1, that's a 3. All right, here we drop the power, so it's minus half times 2. On your calculator, that's negative 1. So it was going to be negative x. All right, if we subtract 1, that's negative 1x, negative x. 5 is a constant. Its derivative is what? That's a 0. So you're going to add a 0, guys. Adding a 0, that's nothing. All right, so go through the introduction where we talked about how to differentiate this. Drop the power d of what? Ax to the exponent of n is anx to the exponent of n minus 1. Drop the power, subtract 1. And that is the concept that we're going to apply throughout. Now you use the general rule throughout. 8.22 throughout. All right. So, but we have to rewrite our expressions must be in this form so that we can properly differentiate. So if we check on 8.22, we are limited. There is a square root there. So y is equal to, remember, square root, there's a 2. And this is 1, so it's to the exponent of what? 1 over 2. X to the exponent of 1 over 2 over 2. All right. This is same as like 1 over 2. All right. What about this? It is in the denominator. Let us take it up It's going to be a negative exponent. So it's going to be negative 1 over 9x to the exponent of what? A negative 3. So you have to get rid of this in the denominator. So that is why, guys, what you can see, half of x to the exponent of a half minus 1 over 9, x to the exponent of what? X to the exponent of negative 3, where we can properly see our a, x to the exponent of n. So we can differentiate where the derivative is going to be. You drop the power, then you subtract a 1 from that power. So half times half is going to be 1 over 2. 1 over 2, that's 1 over 4. 1 over 2 times 1 over 2, that's 1 over 4. X to the exponent of what? 1 over 2 minus 1, that's minus 1 over 2. It's going to be a negative. Use your calculator. You do the same thing here. You drop the power, then subtract 1. So it was going to be negative 1 over 9 times 3. Negative 1 over 9 times negative 3. And that was going to give us 1 over 3. So that's positive 1 over 3. So it was going to be positive 1 over 3. X to the exponent of what? Negative 3, negative 1. That's a negative what? A negative 4. There's no need for you to simplify further. There, we are not told leave your answer as positive exponents, this and that. So leave your answer as it is like this. You can obtain full marks from there. All right, let us consider 8.23 to find the first derivative if our f of x is given as that fraction. And as you can see, it is actually difficult for us to differentiate direct the fraction the way that we are given. So according to our syllabus, we can easily factorize the numerator, all right? As we are given the linear expression in the denominator, factorize this, all right? So the way you're gonna factorize, guys, it is in your hands, all right? But what I want you to do is to factorize using any way that you understand, that you've been taught. All right. So that is it. Let me just use my way here, which is in my case, I'm going to use the cheat method where I have to get rid of these 2, multiply it to the constant. So it's going to be x squared minus 3x, that's times 2 here. 5 times 2, that's 10. So it's a negative 10. Then I can factorize this from this factors of negative 10, which will add up to negative 3, that's negative 5 and 2. If you multiply this, you get a negative 10. If you add, you get a negative 3. So that's negative 5 and positive 2. Then I bring this 2 back in place of x. I put a 2 here, I put a 2. Then I factor out where it is common. This 2 is common, so it's going to be 2x and 2. That's x plus what? X plus 1. So I can get rid of this. All right, so this is what I'm going to have, 2x minus 5x plus 1. Those are the 2 brackets that you must obtain. Guys, there are so many ways. I'm going to show you guys so many ways. There's just issue of time. You see, guys, if we've got more time, we're gonna explain so many ways so that you are not limited. There are so many ways that you can actually use in your factorization. Just go through the textbooks that you are using, find the way that you can see, all right, this one is the best, then apply that. All right, as we can see, x plus 1 and x plus 1, these 2 are the same. They can cancel. So I was going to remain with what? 2x minus 5. So our f of x is equal to 2x minus 5. We can find the first derivative from there. It is something that we are used to. All right, 2x is a linear from our ax. The derivative is going to give us what? The coefficient of x, which is what? Which is in case it's 2. A constant, its derivative is 0. So it was going to be 2 minus 0, which is what? Which is 2. So that is our first derivative from what we're given. Factorize the numerator, simplify where it is what applicable or where it is possible. That is the whole idea there. All right, let us consider this part All right, 8.3, that was 7 marks. All right, let's see why 7 marks. The tangent to the curve y is equal to minus x squared plus 4x is perpendicular to the line, all right, to this one. All right, so we are talking about a tangent there to a certain curve. In this case, maybe something like this, then it is what? The tangent, then it is perpendicular to a certain line. So our tangent, the one that we are actually focusing on, what is its gradient? It follows that for two lines that are perpendicular, the product of their gradients gives us a negative. So meaning to say the gradient of the tangent that we want times the gradient of the line where the one that it is perpendicular to this line. We can have our gradient here. What is our gradient here? That is half. Y is equal to mx plus c. M is the gradient. So times 1 over 2, it is supposed to give us negative 1. So what is the gradient of the tangent from there? Divide by 1 over 2. That was going to give us a negative 2, right? If we divide by 1 over 2, you're going to obtain a negative what? A negative 2. So this is the gradient of the tangent. What's the importance of this gradient if we do not have a point? Because we need to find the equation. So we only have the gradient. We can find the point on a condition of our tangents now to say the tangent and the curve, where they meet, it follows that the first derivative of our f of x, which is our dy dx from here, is supposed to be equal to the gradient of the tangent. Remember, I talked about that. So you must find the first derivative, which is drop the power here. It's going to be negative 2x plus what? Plus 4. The coefficient of x, this is a linear, so the coefficient of x is 4. It must be equal to the gradient of what? The tangent, which is negative 2. You have formed an equation where you can solve for x. Why solving for x? Because we need that as a point. If we've got a gradient and a point, we can have what? An equation. So we need to solve for x. Minus 2x is equal to 4 to the other side. That will be negative. So that's negative 2, negative 4, negative 6. Divide by negative 2 by negative 2. X is going to be equal to what? Positive 3. So this is where the tangent and the curve meet. All right. That's at what? X is equal to 3. So you can find the y value where x is equal to 3 by substituting into the original function where y is equal to what? Minus x squared plus 4x. So it's going to be minus our x is what? 3 plus 4x, 4 times 3. All right, so this was going to give us the value of y. The negative is out of the bracket. All right, take note, the negative is out of the bracket. So that's plus 4 times what? 4 times 3, which is going to give us a positive 3. So at the point of tangents, x is equal to 3, y is equal to 3. So we have the gradient of the tangent. We also have a point, which is the point of what? Of tangents, where x is 3 and y is equal to 3. So with this, we can find the equation of the tangent, guys. Remember, our question here is to find what? The equation of the tangent, which is given by the equation y is equal to mx plus c, where m is the gradient, and the gradient of the tangent, we know it's what? Negative 2. So now we're going to need the value of c from the point. X is 3, y is 3. So 3 is equal to minus 2 times 3 plus c. So 3 is equal to negative 6 if you multiply. Then you take the negative 6 to the other side. That was going to be a positive 6. So that's 3 plus 6, which is what? Which is 9. So c is equal to what? C is equal to 9. Thus, our equation is going to be minus 2x plus c, which is minus 2x plus our c, the y-intercept is what? Is 9 from there. So you see, guys, it's just a matter of playing around with the questions, playing around. But that was it. That was it on 8.3, a total of what? A total of 7 marks and 21 marks for the total of question 8, I mean. Then question number 9, moving on to question number 9, where we've got our f of x. So in this case, we are given our f of x, which is minus 2x, this and that, right? Then here we are asked to solve, all right, 9.1, solve for x if f of x is equal to what? 0. All right, so remember I talked about using the long division, all right, when you're dealing with a cubic function. There are so many ways that you can actually use again on this factorization of a cubic function. But for the sake of time and so on, I'll just refer to what I've introduced, but there are so many methods, all right? So you needed this when f of x is equal to what? Is equal to 0. You take your cubic function, minus 2x cubed, all right, plus 5x squared, plus 4x plus 3, all right, that's a minus here, minus 3. All right, that's equal to 0. So actually, we can avoid working with the negative on the coefficient of what? X cubed. So simply divide by what? -1 throughout. By -1, it does not affect your solutions, all right? So that's 2x cubed, negative 5x squared, negative 4x, negative, negative, that will be positive 3, and that's equal to 0. So there are so many ways of factorizing this f of x, all right? Long division, the synthetic division, and so many. So I'm just gonna explain about the long division, which is a little bit lengthy, uh, just because I explained about that before, like, and also the synthetic division. Then as time goes on, I'm going to bring back these questions separately using other methods. So do not worry about that. Just apply the method that you have been taught for now and see if you're going to obtain the same answers at the end. All right. So using the long division, I'm going to need a factor from the constant 3. I need factors of 3 plus or minus 1 plus or minus 3. All right, so substituting 1, f of 1 in place of x, you're going to substitute 1 in place of x, and so on and so on until you obtain a 0. So you're going to see that f of 1 was going to give us a -4, not a 0. All right, then f of minus 1, if you substitute -1 throughout, you are going to obtain a 0, f of 1. So therefore, from that -1, it follows that x plus 1 is a what? Is a factor. Remember, this is what I taught you guys. From the -1, you write it as a positive when it is a factor. Then you apply your long division from there. All right, where our factor is what? Is x plus 1. So it's going to be x plus 1 into what? The cubic here that we now have at this point. So just use the method that you understand for now. Like I said, I'm gonna explain this later on. So remember our division, I said, is always first term to the first term. 2x cubed divided by x, that's 2x squared. All right, so it's gonna be 2x squared. Then after dividing, remember you multiply everything by 2x squared. So it's 2x squared by x plus 1. So it's going to be 2x cubed plus what? Plus 2x squared. All right, then we subtract. This one minus this one, that's a 0. Minus 5 minus 2, that's minus 7. Minus 7x squared. The remaining terms, you're just going to drop them down. Minus 4x plus what? Plus 3. Then divide again as it is first term to the first term. Minus 7 times, sorry, I'm dividing minus 7 divided by this. Minus 7x squared divided by x. That's going to be minus 7x. Then minus 7x multiplies back everything. So it's minus 7x times x minus 7x squared times 1 minus 7x. Then we subtract. All right, so this is what you're going to have Subtracting these two simply cancels, they're the same, remember? So minus 4 minus minus 7 is going to be minus 4 plus 7, a minus and a minus. So that's 7 minus 4, which is what? 3x. So it's going to be 3x. You drop the remaining term, which is what? Which is 3. So that's plus 3 here. Divide by x again. I mean 3x and x here. First term to the first term until you get a 0. So 3x divided by 3x, that's going to be positive 3. Then you multiply by 3 each and every term in x plus 1. So that's 3 times x plus 1, which is 3x plus what? Plus 3. Subtract here, you're going to obtain what? A 0. So that's our f of x being divided from this, or being factorized. This whole part is going to be x plus 1 into what we obtained here, 2x squared, into 2x squared minus what? Minus 7x plus 3 is equal to 0. So using any method or any way of your factorization, you are going to have this bracket and this bracket. You see now. Then you can factorize your quadratic again in the way that you understand. So there, I'm not going to waste your time. From the quadratic, if you are going to factorize in any other way that you understand, you're going to obtain x minus 3, 2x minus 1. So make sure that you factorize properly. Then you can obtain the x values from there. 1 to the other side is going to be a negative 1. All right? Or our x is going to be minus 3 to the other side is going to be a positive 3, or x is equal to minus 1 to the other side is 1. Then you divide by what? You divide by 2. So that will be the values of x from what you're given. So like I said, this factorization part, please do factorize in the way that you understand, all right? For now, we can use the methods that we have introduced on the channel so that it will be easier for you to follow up, but I'm going to introduce other ways so that you can understand from there. There is also the synthetic division, which is applied from the value of x that you obtained. All right, from the value of x that you obtained using the synthetic division, it will be like this. You just gonna take the coefficients of this cubic A, B, C, D like that. Our A, the coefficient of what? Of x cubed is 2. Our B is negative 5. Our C is negative 4. Our D is 3. So the synthetic division now applies to the value of x, which gave us a 0, not the factor. The factor is for the long division, but this one is not, it is applied on the value of x. The value of x which gave us a 0, which is what? Negative 1, is the one that we use when x is negative 1. All right, so here it follows that our a of the cubic function is the same as the a of our quadratic function that you're going to obtain. So you just skip this and write 2 here. All right, so remember your multiplication, how you multiply. Negative 1 times 2, you write it in this box. All right, negative 1 times 2, that's a negative 2. Then what is that you do? You add. So this time you add. So adding these two, you're going to obtain a negative 7. All right, the same thing with our negative 1. Our negative 1 multiplies 7. We write it in the next box. So negative 1 times 7, this is going to give us a positive 7. You add these two, negative 4 plus 7, that's what? That's a positive 3. All right, the same thing, negative 1 multiplies 3, you write it here. So it was going to give us a negative 3. Then we add 3 plus minus 3, that's a 0, until you obtain a 0. So from the synthetic division, it follows that the last, these ones in the last, or these terms, these ones, A, B, and C, these ones, they are the coefficient of the quadratic ax squared plus bx plus c. So therefore, that whole part being factorized, remember x minus 1, x is equal to minus 1, is the is the solution, not a factor. So the factor was x plus 1, the one that I raised. So it was going to be x plus 1 into the quadratic. Our a is 2. So that's 2x squared. Our b is negative 7. So that's negative 7x. Our c is the constant, which is what? Which is 3. So this is what you're going to have. As you can see, we are back to this one that we had here. And that is equal to what? That is equal to 0. You can solve from there, from what we are having. So like I said, here it is just because of what? It is just because of the methods that I have introduced before, to say those are the ones that I have introduced. So you can factorize just like this, then you find your solutions. But there are other ways. So as time goes on after this lesson paper, I'm going to bring back that in a playlist again of these different ways or methods of our solving of the cubic function of that cubic equation actually, or factorization of a what? A cubic function, all right? Those third degree what polynomials. So you see, as time goes on, so that solving that we're just doing here, guys, it is finding of the x-intercepts of this function that you're given here, because it was taken from that f. This is the graph of f of x. So when we are saying f of x is equal to 0, that is y is equal to 0. Those are the x-intercepts. So the values that we obtained when we solved here, it was what? Negative 1. Negative 1 is going to be representing a on the negative. So that's negative 1. On the positive, there is d and what? D and f. So d is going to be the smaller one, closer to the x-axis. So our d, that's a half, and f is going to be what? 3, the bigger value there, which is what? Which is a 3. All right. From those solutions, that is what it actually mean. All right. Anyways, let us see what we are given here. 9.2, calculate the coordinates of B and E, the turning points of what? F. All right. So the turning points, we can apply the derivative, guys, for us not to waste our time. This is where we've got B and E. And those are what? And those are turning points. So we do understand that at the turning point, the condition is about what? The first derivative, all right? That is the condition of our turning point to find our B and E. The condition there is about the derivative. So let us remove this. It's all about the derivative. The first derivative must be equal to 0, all right? So that's our 9.2. B and E are what? Turning points. So these are turning points. And at the turning point, the first derivative is equal to what? 0, the first derivative with respect to x. So let us find our first derivative from our f of x. All right, drop the power here, subtract 1. So 3 times minus 2, that's minus 6x squared. 3 minus 1, that's 2. All right, drop the power on this one. 2 times 5, that's 10. So it's going to be 10x. Subtract 1, and 4x is a linear. So that's going to be plus 4. Minus 3 is a constant, so that's a 0. So this is your first derivative, the one that we are saying it must be equal to 0. So you have to form an equation. Minus 6x squared plus 10x plus 4 must be equal to what? Must be equal to 0, so that you can solve for x. All right, let us make this positive. Simply divide by the highest common factor, negative 2. All right, that will be negative 2 throughout. Negative, negative, that's a positive. This will be 3x squared. 10 and negative 2, that's negative 5. 4 and negative 2, that's negative 2. And this is equal to 0. So from there, you can solve this. You can use your factorization. You can use your quadratic formula. All right. So if you are using factorization, like I said, guys, there are so many ways of factorizing. You are going to obtain the bracket of x minus 2 into 3x plus 1. This is what you're going to have, where x is what? Minus 2 to the other side will be a positive, or x is equal to minus 1 over 3. You have to divide by 3. So that is what we have. These are the x values. Since we have got two turning points, One of these represents B. So B is on the negative side. That's going to be minus a third. So definitely that's the X value at B minus a third. And the X value at E must be positive. That's definitely what? A 2 that we are having here. All right, where it is positive. So therefore, the coordinates, we have to substitute back into our f of x, the original equation. After solving these x values, you substitute back to the what? Original equation, the one that you had here, your f of x, the values of x that you have at b. All right, so that's at what? At b, where our x is equal to what? Minus a third. Substitute that. That's going to be f of what? Minus a third. Meaning to say in place of x, put minus a third. So that's minus 2 into minus a third to the exponent of 3 plus 5 minus a third to the exponent of 2 plus 4. This is minus a third minus what? Minus 3, as it is from your f of x. So you're going to substitute this as it is. All right, that is going to give us the value of y. By substituting the value of x, you obtain the value of y from there. All right, using your calculator properly, that was going to give you negative 100 over what? 27. That's the coordinate, or that's the point B. All right, so therefore, our B is going to be given as x minus a third, and y is what? Minus 100 over what? Over 27. All right, so this is minus 100 over what? Over 27. That's for the point B. All right, another point is the point E. So for the point E, what is it that we are considering? That is at E, the X value, remember it's what? It's 2 from those conditions. So you simply need f of what? F of 2 into the original function, that's minus 2. In place of x, 2 to the exponent of 3 plus 5. In place of x, that's what? 2. So that's 2 squared plus 4. In place of x, we're going to put what? We're going to put 2 like that. So it is simply substituting those into the original function like that. So this was going to give us 9. So that's the point E is going to be given as when x is what? When x is 2, y is what? Y is 9. That's f of what? F of 2. So that was the condition, all right, of our turning points B and what? B and E. So that is it. Here is 2, 9. This one we said minus a third minus 100 over what? 27. All right, so that is it. Let us move on to another part of the question, which is 9.3. For which values of x will the graph concave down? All right, is the graph concave down actually? All right, so remember when you are to consider how concave the graph is it concave down or is it concave up? You are supposed to consider what? The second derivative. All right. So when it is concave down, the second derivative with respect to x has to be what? Less than 0. So that is the whole idea of what you're going to have there. All right. So let us solve that. The second derivative, remember we've got the first derivative. All right, it's just that I erased it. But remember, we calculated the first derivative. When you're calculating the turning points, our first derivative, it gave us minus 6x squared plus 10x, if you still remember, plus 4. That was our first derivative. It's only that I erased that one. But you're going to continue from where you had the first derivative on question 9.2 here. All right. So when it is concave up, second derivative is what? Less than 0. So let us simply find that. All right. That's our 9.3. So 9.3, the second derivative with respect to x has to be less than 0. That's being what? Concave down. So this is the condition of a function to be concave down. So let's determine our second derivative with respect to x. So just like before, guys, drop the power, subtract 1. This you multiply, that's negative 12x. All right, a linear, take the coefficient of x, that's positive 10. C is a constant, so just a 0 there. So this is your second derivative, which I'm saying it is what? It is less than 0. So from here, you're going to solve minus 12x plus 10 being less than 0. Second derivative being less than 0. So let us solve for x from there. This is an inequality. 10 is going to change into a negative, then divide by negative 12. The moment you divide by this negative, remember that the inequality sign reverses or changes. So it's going to be greater than, all right? 10 over 12, that's going to be 5 over 6. So these are the values of x that we're going to have for values of x which are greater than what? Which are greater than 5 over 6. All right, so that was the condition for being concave up. X has to be at that point 5 over 6 and so on. All right, so that is it, guys. Please do revise. And considering this one, for which values of x will x times the first derivative of x be greater than what? Greater than 0. All right, this one we're just going to need our graph. We need the graph here. All right, that's 9.4. Remember, I talked about this again, like I was saying before, you just need a playlist where we know the effects that will happen to each and every type of those calculations. They were given x times the first derivative of what? Of x, where it is greater than 0, where it is going to give us what? A positive. If you multiply, this is going to give us what? A positive greater than 0. So we need critical values. All these guys are about critical values. So in our case, the critical values for when we are to consider x, all right, in our case, we are going to consider x. X is also part of our consideration. So we consider where x is equal to what? Where x is equal to 0. That part is supposed to be considered for x when it is just x. When you solve critical value, x is equal to what? X is equal to 0. That's a critical value. So x has to be equal to 0. Then for the first derivative, remember I said, guys, when you're dealing with the first derivative like this, you work with the turning points. All right. So our turning points, the x value we need at b, where x is what? Minus a third. So x is minus a third is a critical value. And another turning point at e, where x is what? Where x is a 2. So these are the critical values. X is equal to minus a third at a turning point. All right. X is equal to 0. This one is for x, solving for x. X is equal to 0. It automatically becomes a critical what? A critical point, this one. So that's it at x is equal to 0. And another turning point here at x is equal to e, where x is what? Where x is 2. So we need a condition where we take the x value, multiply it to the first derivative, and we obtain what? And we obtain a value which is what? A positive. So x can be positive, and the first derivative has to be positive, or x can be negative, the first derivative has to be negative. How do we know that the first derivative is negative? When the graph, that's why we needed the turning points. When the graph is decreasing, all right, when the graph is decreasing from this turning point, where there is a decrease, the first derivative is a negative, where there is a decrease. Where there is an increase, the first derivative is what? The first derivative is positive for an increase. For a decrease, that's how you attempt this. X values, they are easier, guys. You can tell from this from the origin going this side, you can see that x is negative or x is positive. So there is nothing about that. You simply have to look into the graph. All right. So let's start with our critical value. Remember, the first critical value is what? -3, -1/3. So we are looking into this side of our -1/3. What is happening on that condition up to the turning point here? The graph is going down. That's a decrease throughout. That's a decrease. Meaning to say our first derivative is a negative. There is a decrease. What about the x values? The x values, guys, we're talking about -1/3, -1, -2, -3. The x values, they are negative there. So the x values, they are negative. The first derivative, because the graph is decreasing, it means the first derivative is what? Is a negative. So we are multiplying a value of x, which is negative, to a first derivative, which is a negative. So we are going to get what? A positive, exactly what we want. So this must be part of our solution, where x is what? Where x is less than 1/3. This region is part of our solution. X is less than what? -1/3. All right? Since 0 is a critical point, we are going to consider in between 0 and in between -1/3 and a 0. 0 became a critical value because of x, guys. It's a product, so x is equal to 0. So from -1/3 up to 0, in between here, what is happening? Our function, because b is a turning point, our function is now going up. Our function is increasing, going up. It's a positive. But what is happening about the x values? In between -1/3 and a 0, guys, the values of x, they are negative. So we are multiplying a negative to a positive. This is not what we want. So in between -1/3 and a 0, there is no solution here. It does not satisfy our inequality. We do not have a solution between that. It's a critical point at x is equal to 0, remember. But it is now between another point, you have to take them in between. Just like what is happening here between 0 and 2, because this one is a critical point. You take in between to say between these 2 points, what is happening between 0 and 2? When x is 0 here and when x is 2, what is happening this time, all right? Let us check what is happening. Between 0 and 2, the x values are positive. As you can see, they're going to the positive now. X values from 0 to 2, they are positive, the x values. What about the first derivative? The first derivative, we are looking into the function. Is it increasing or decreasing? The function is increasing. Look what is happening. It's going up. So the first derivative is a positive for an increase. So positive times positive, exactly what we want. So we will need this region in between 0 and 2. From 0 to 2, we need that. So it's another part of our solution where x is greater than 0, but less than what? But less than 2. Another part that we must consider, because 2 is a critical value, we must consider after that 2, values greater than 2. What is happening for values that are greater than 2? What is happening for these values greater than 2? We can see that for these values, all right, sorry for that. Let's see here. For these values that are greater than 2, we can see that, all right, this here is going to be like this. For these values greater than 2, we can see that our x values, they are positive, all right? Starting with x values, they are still in the positive. And our function is decreasing because at 2, that's our turning point. So our function now is decreasing. It's what? A negative. So we are back. Positive times negative gives us a negative. We do not want that region. We want a region that gives us a positive. So this was going to be the final solution from what we had, where x is multiplied to the what? To the first derivative of f of x. Just like that. So you must be very careful, guys. Very, very careful how you attempt these typical questions. The critical value, x is part of what? The critical value where x is equal to what? Where x is equal to 0. All right, so that is how you play around this type of a question. Let us consider another part on our question 9. This time, they're asking on 9.5, for which values of k will 2x cubed this and that equal to k? You have three roots. All right, so this is the type of question that they'll ask you, for which values of k will this have three distinct roots, three different roots. All right, three roots, they will be different since our f of x has got three different roots. All right, so if we check here, this is not our f of x, this one. Our f of x was given with negative. This was a negative 2x cubed plus 5x squared and so on. So if we check this one, it's now positive 2x cubed. What happened is that they simply divided our f of x here by negative, each and every term by -1, by -1, by -1. Look, that is what happened. And got 2x cubed minus what? Minus 5x squared minus 4x plus what? Plus 3, which is this one that we are given here. So you must be very careful, this one. This here is what? Minus f of x, what we are seeing here. It's minus f of x, which is equal to k. All right. So if you know that is minus f of x, ask yourself to say, what about if it was f of x? What are the conditions that will give us what? Will give us three roots, meaning to say there are different roots that we are referring about here from our f of x. What are the conditions that when f of x is equal to k, we've got three different roots? Remember, k is such that it is greater than or less, here it must be greater than the y value. These are the you consider turning points. All right, at the turning points, the y value at the turning point, the minimum, like here, the turning point, the y value, the minimum, it's minus 100 over 27. All right, but less than the y value at the maximum here, turning point, which is what? Which is 9. That is how we answer this. We are done. But in our case, they are not asking for f of x, guys. They are asking for what? Minus f of x. So if our minus f of x, if we are considering, I mean, minus f of x, what does it mean? All right. F of x is equal to what? It is equal to k. What about when I say minus f of x? It means I introduced a negative. I must also introduce a negative there. So minus f of x equals to minus k. This k was for what? For f of x. So when it is now minus f of x, so here for y is equal to minus f of x, we are going to have that one as minus k. Minus k will be greater than minus 100 over 27, less than 9, like this. You put a negative for that k because you have what? Affected everything with a negative from that f of x. So the k becomes a negative. That is the whole idea there. So you solve for k. This is minus k. We need values of k, not minus k. So how can we find k? Divide by what? Negative. Remember the concept, guys, of your inequalities from your grade 10. The moment you divide by negative like this, the inequality sign reverses. All right, the inequality sign changes. So it was greater than, it will be less than, like this. K is less than negative, negative. You're going to obtain positive 100 over 27. Here it was less than, k is less than this, but the moment you divide by negative, it reverses that inequality sign. So k is now greater than 9 divided by -1. That's a negative what? A -9. So the inequality signs, they reverse. So what does this actually mean? From the smaller value, k is greater than what? K is greater than -9. But the same k is what to this one? It is less than. K is pointed by 100 over 27. That is your final solution from there. All right, you can conclude in that manner. All right, so this is it. This is the whole idea on question number 9.5. That was, I meant on question 9.5, 3 marks, all right? So be very careful about when it is a negative like that. All right, on question number 10, which was actually the last part of our question here, we were given, all right, let's try to figure out, they were given f of x is this, and from our real numbers, and the turning points of f are these. These are the turning points where a is greater than b. At the turning points, a is greater than b. All right. Which points p and q represent the minimum and maximum turning point? All right. Remember, we are told that p is greater than 0. So p is for the shape of the cubic function. When p is greater than 0, it means our shape is like this. So there are two turning points here, the maximum turning point, the minimum turning point. So as the values are being represented, we are told that a is greater than 0, meaning to say a is more positive compared to b. So this can happen at point A. All right. And this can happen at what? At point B. This is what it means. So A is greater than what B? A is on the positive side. So which of these two now is the turning point? Remember, A is taken from what? From point P. This is our point P, which is A, F of what? F of A, like that. From point P. Then B is taken from what? From point Q. So which one represents the maximum minimum? So the minimum turning point, that's P at A. Look here according to the shape. So the minimum turning point is what? Is P. So P, that's our minimum turning point, and the Q will represent what? Will represent the maximum turning point. From this knowledge alone that we are given, from this understanding alone, we can tell that that is what exactly is happening. 10.2, is f of x increasing or decreasing for x is greater than a? All right, this is where our a is at the minimum turning point. Remember, this is our minimum turning point. So for values of x that are greater than a, the graph is going up. That's increasing from there. From the minimum turning point, you're now going up. From the minimum turning point, the graph is now going up. Where x is greater than a, the graph is what? Increasing. All right? 10.3, write down the coordinates of the y-intercept. All right, the coordinates of what? The y-intercept of the first derivative of what? X, the first derivative. So we must find that first derivative, all right? So the first derivative of x, simply here, we're going to drop the power, subtract 1. So this is going to give us 3p x squared. All right. Here also do the same. Drop the power, subtract 1. So it's going to be 2qx. All right. Rx. Remember, these are constants. R is a constant. So the derivative of Rx is going to be R there. A linear, you take the coefficient of x. All right. So the first derivative represents what type of a graph? X squared. This is x squared. So that's a parabola, a quadratic. So on a quadratic, what is the y-intercept? The y-intercept is the constant. Y is equal to ax squared plus bx plus what plus c. So the constant is our r there, where x is equal to what? Where x is equal to 0, y is equal to r. The value there, the y-intercept is what? Is r. So that is our y-intercept. You compare from that first derivative. It's now a function. You treat it as a function. That is the way that they want you to answer this question. All right. On 10.4, write down giving a reason the value of what? The value of the first derivative of x if x is equal to b. All right, so guys, let's check. If x is equal to b, remember a and b, they are turning points. So at a condition where x is equal to b, it corresponds to the what? To the turning point. It's a turning point. So what is that we know about this? When this is a turning point, at b, it's a turning point. So the first derivative is equal to what? We don't need to calculate that. We know. We know it. It is equal to 0. Since what? At b, at x is equal to b is a what? Is a turning point. That's the value of x at the turning point. And at the turning point, the first derivative is equal to 0. So that was it. Just like that, guys. All right. Then 10.5, you are given, write down the coordinates of the x-intercept of this y is equal to 6px plus 2q in terms of a and b. The coordinates of the x-intercept. All right, I want us to see what is happening here when we are given y is equal to 6px plus 2q. This equation that we are given here, if we check, guys, it was taken from the first derivative here. From the first derivative, we differentiated and obtained the second derivative. 3 times this, 2 times this 3, it was going to give us 6px. Remember, you subtract 1. 2qx. 2q is a constant, so you take that 2q. Then r is a constant. The derivative with respect to x is going to give us what? A 0, because r is a constant. So this y that we are seeing, it's the second derivative, guys, this one. It is simply was taken from the second derivative. So if it was taken from the second derivative, where x is equal to 0, considering that we are dealing with the second here, guys, look what is happening. I want you to understand. This was the second derivative. And they are saying you are supposed to calculate the coordinates of the x-intercept. What are the conditions for x-intercept? Y is equal to 0. And y here is what? Your second derivative. Y here, y is equal to. So if we are saying y is equal to 0, we are simply saying the second derivative with respect to x is equal to 0. Which condition is this? That is what they're asking you. It's like reversing your knowledge. Which condition that you understand? This is the point of inflection, isn't it? Where the second derivative is equal to 0. We're talking about what? The point of what? Inflection. This is our point of inflection, remember. So if it is the point of inflection, how can we obtain our answers now for that x in terms of a and b? Guys, from the point, from the turning points here, from these turning points, these are the turning points. Remember here, these are the turning points. The point of inflection will be in between the turning points. That's our point of inflection. So at the point of inflection, at that point, x is equal to the average of these x values at the turning point. The average, that's a plus b over what? Over 2. At that turning point, the average of the turning points gives us the point of what? The point of inflection. All right? So it's another aspect, very, very important for you to understand. So you're simply going to use the average concept from the what? From the turning point concept. The x at A, this was B, this was the x at A. These are the turning points. The point of inflection will be in between. So that's the x value. The x value, remember I talk about the x-intercept. So the x value at the point of inflection is given by A plus B over 2. The values of x at the turning point, their average. Their average. So that is it. So therefore, our x-intercept at the end was going to be a plus b over 2. And the y value is what? 0. Remember, I was saying y is 0, the second derivative. So it's an application. This type of equation is an application. They want you to, like, do you understand the topic? Or you memorize the basics? Yes, an understanding. Do you actually understand your topic? This is question number 10. So do yourself a favor, guys. Understand all the basics. All right? Understand all the basics. That is the most important aspect for revision. It's going to help you a lot. All right, so that is what we had on question number 10, having 10 marks and a total of 150 marks. So guys, that is it. Let there be light in our revisions as we are revising. Let there be light, guys, and let us continue to work out as many questions as we can. Where we do not understand, let us communicate through the comment section, through the community section as well, for topics that you do not understand, or for a question that you do not understand. You can capture that question, send it on the community section, so that when I have time, I'm going to work on that question. Or if there's a way of calculating that you have been doing, then you need an understanding from that. Let us utilize the community section. Community section is where we can learn more, because we communicate through what you are doing. All right, through what you're doing. If you're doing something, take a picture of that, send it there. Then I can reply as a video that can help you understand more from what you are doing. So that is it, guys. Till we meet again.